Hit start. And this thing goes green and it says excellent, but then I don't get any kind of a preview. It'll eventually, there it goes. Yeah, excellent, but no preview. So I have no idea what we look like in vertical format. I'm probably off screen right now. It's probably taking a chunk out of the middle of the screen. Let's see, maybe if I reload, it'll show me. It would be nice to at least know where things lie. Herc! It's trying, it's trying. You know, like, this stuff is not that difficult. Yeah, there it is. It's, oh boy, it's right in the center, isn't it? That's hard to see. I guess I am. Okay, so I'm in a window, in a window, in a window. But if I move that off screen, then yeah, we're just looking at the dead center. Okay, if you want to force me to do this, YouTube, it's not gonna look pretty because I have a little bit of asymmetry to the visuals here. I have the stuff and then I have the me over to the side, and there's more stuff over here. So like I'm being half cut in half by the frame. So whatever, as I contribute to electronic waste in terms of just data. I'm just putting random ass data. Here, train your algorithms on this, idiot. Put Minecraft parkour. I need like keys jingling for the vertical format stuff. This is going to affect how I kind of organize things around here, isn't it? So YouTubers, you're not hearing any music. I'm playing music just to fill noise while I set up everything here for streaming. So you're not hearing that. It's only on Twitch, and it's only live on Twitch. The music is not stored in any way. That's how we get around copyrights here. But we're going to be taking a look at filters. We're going to look at this MS-22 filter, and for all the work that it's been getting this thing up and running, is it worth it? I don't know. Julian says it's really good. Dave likes the one that he has, and I have now built it by ordering a ton of parts and doing some genuinely difficult soldering. It's actually, there's some genuinely difficult soldering in this thing. I'm happy that it is where it is. We'll just see if we can actually get it working for us. And we got a ton of other filters that I need to get to. I got all these sitting back here that we need to characterize and figure out. But we're gonna do the engineering thing. We're not gonna like listen to it as musical instruments. We're gonna tune it like engineers. So yeah, put Minecraft parkour on the bottom, half of the vertical video. That'll make them happy. Yeah, there you go. Just have, or you know, a picture of Willow just in there. I think she shows up on the, here, let's just check if my Willow preview, does that actually, yeah, it's like stuffed in the corner. It barely shows up. Like the right-hand side of that window is the border of the vertical. But there you go. There's your jingling keys. I'm jingling the keys for everybody. With pictures of my dog. That's my dog. Her name is Willow. She's my whole world. No more Willow. Wait, what did I just click? Oh. That's, wait, does that still line up? Does that, kind of, a little bit. I need to put this back. I gotta remember that that's there. I gotta remember that. It's a good gag if I don't tell anybody about it. Hey, what's up, Akita? All right, let's get YouTube chat running here. I'm still not set up fully. I need to run all of my stuff. What's going on? We got some really interesting stuff to do today. It's going to look really cool on screen because we get to do FFTs and stuff. There we go. So now we got Akita up on screen. Cool. Doink, doink. Yeah, so the MS-22 is some pretty good tuning instructions, but they're using MM audio tools, which is what I used to use for my microphone, through Ableton. And I think I have a pirated copy of Ableton, but we're not going to use it. I'm going to use my own tools, my own fast Fourier transform things to characterize the frequencies that this thing is putting out. Last time I did brakes on my own cars, I rebuilt the caliper and it was surprisingly easy. Yeah, they've kind of simplified brakes down to like a science, as long as you don't have drum brakes. Drum brakes are sort of Satan's spring puzzle that you have to put back together, and really helps when you're doing drum brakes specifically, if you have a drum brake tool. It's like a specific kind of like wrench that'll help you get some of those nasty springs back into position without too much worry. And if you don't get the tool, you can still fix your brakes. You can still fix your drum brakes, but it's gonna suck. Like, it's worth the cost, the $15 for the tool, when you're working on drum brakes. With piston brakes, it's really just how much do you weigh. If you weigh enough, you can just put your weight on it and reset the caliper. Sometimes you can just squeeze it. That sucks. So you can get a C-clamp, or you can get a specific caliper tool that you just boop, 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 and it's done. And you're like, why did I buy this tool? I don't need it. Well, the tool saved you about an hour. So I haven't done a brake job in a long time. I have not been driving. I have not been driving at all. And my car's run out of registration and I need to get it inspected. I don't think it'll pass an inspection. Actually, I think it'll probably pass an inspection, but it shouldn't need to be inspected. I should register it as like classic, and I'll see if I need to get an inspection that way. Before I moved, one of my neighbors asked if I could replace her brakes for her, and I don't like working on other people's brakes to begin with, but when I saw she had drums in the rear, I told her I wasn't comfortable doing it. Yeah, it's like, I don't want to be responsible for not putting the drum back together properly. If they're expensive, nice drum brakes, they should tune themselves. But if they're BMW parking brake drums, you have to stick a screwdriver in there to expand a little thing that'll get them to be in partial contact, and then your parking brake will never feel right again. That's how it is with my car. My parking brake only engages at the very top, and I need to basically stick a screwdriver into it to expand out the bottom of the drum brakes so that they put a little bit of resistance on the drum at all times. If classic rules in PA are anything like Virginia's, you can't register your car as a classic if it's your only one. I don't think they do that in Pennsylvania. In Virginia, there's like a personal property thing going on with cars. Yeah, I'm not sure how. I don't think that's the way. I mean, they should do that here. That seems reasonable, but and then, I'm not sure if I'm gonna even bother with that, because then you get pulled over at night. If the cop cares at all, I might just register it as a regular car and use it as well, I haven't been using it at all. I've got a solar panel in there keeping the battery up. I'm not really sure how well that's working for it. It's under a tree, so there's plenty of shade, which is bad for the solar panel, but I think it's been sort of somewhat trying to maintain. Bigger issues, the inspections. Yeah, I mean, I don't know what Pennsylvania does, if they waive the inspection when you do classic. I'm not totally certain. It's weird to look over and see myself talking 10 minutes ago. The preview is really far behind on the on YouTube. Yeah, it's so far behind that I can't. I've yet to move the. Okay, there. Now I'm moving the camera. Is that? Oh, that's too close. We need to be like far away so that it's framed properly. I cannot do this vertical video thing. Going out a proper 5-volt PSU. Those boards looked like they would have been fine. It was so frustrating. Speedy Cat was there. It was so frustrating. Willow idea. You got both things at the same time. Yeah. So like, man. Oh, did his soldering station go kapow? Oh my god. Yeah, apparently he got all that stuff working, but not for want of trying. That was way more work than it should have been. Look at this little vertical preview that I've got going on here. Isn't that cute? Something to do with YouTube making sure that all the kids with their burnt brains can watch my content or something. Yeah, so apparently the power supply was too high volts or something. Yeah, they want less than 5 volts, not more. So you've got Raspberry Pi on one hand that wants more than 5. They want 5.1, which is a weird number. Raspberry Pi gets a little squirrely when it doesn't get its 5.2 volts. And then The Wemos want 5 or less. So they're sensitive in that regard. And I've never had a Wemos do that to me. I've never had a Wemos D1 Mini complain about the power supply on that level before. I've never seen that once. And those power supplies that he was using looked really beefy. I guess they just needed to be linished back a little bit in terms of the power delivery, which is insane. I'm floored. I'm flabbergasted by that level of issue. That's ridiculous. We do not have these problems here because we have a Eurorack power supply we're dealing with. This is my Eurorack module tester, and this is one of those projects where, remember, this is only temporary unless it works, in which case it's permanent. That's what this is. This is able to create a couple different waveforms, and it's a power supply with pretty sensitive current monitoring on it, just in case something is shorted out. This thing has the good modules, the really good modules, the ones from Pololu. I have a USB-C input that is 15 volts that feeds a positive 12 and a negative 12 supply, as well as a 5-volt supply, which I'm going to rely on for the new module tester whenever I can get around to building that stupid thing that has a big VFD display that's going to be really 5-volt hungry. So like, it may look like the module tester is a module, but it's not. It's part of this whole assembly. Just send them a 5-volt, 5-amp PSU with 10% adjustment trim pot. Yeah, that'll certainly get the job done. It's crazy that he had that problem, though. That's unprecedented. It's one of those problems that drives you just completely up the wall. And he was driven up the wall. He spent 5 hours building this thing, and it was literally just +5 signal ground. It's super. It's just a rail. It's like the easiest thing in the world to build. Did all the cable crimping and stuff like that. Got all his ducks in a row. It was literally like power input, power supply, rails. Test that out. Doesn't work. The Wemos doesn't want to power on. What? Check the 5-volt pin. Oh, it's not just a 5-in. It can take 5 volts in that pin. It's totally fine. It could also supply from that pin, but generally you want to put power into the Wemos D1 Mini through that 5-volt pin, and then it just goes to all the rest of the electronics and everybody's happy. Wouldn't turn on. Is it the power supply? Cut out the power supply. Is it this? Do this, redo that, and like 6 hours of work just went up, not up in smoke. That would have been definitive. Up in smoke would have meant we would be able to know what was wrong with it if something blew up. It's nice when in electronics, when you're building stuff in electronics, if something explodes, that's good because you know that thing failed, and now you can focus in on it. But in electronics, when nothing does anything and you've replaced every single piece along the way and it still does the thing, whoa, that's so frustrating. You don't have like a single smoking gun to look at your problem specifically. Yeah, the USB cable was off of the keyboard, and that was outputting like 4.3. Weird. 4.3 would be like a failure for most, because the ESP is doing Wi-Fi. It's using a lot of power to do that and creating a lot of heat. I guess it's so weird that the D1 Mini would want that. I guess maybe it might be down to here. Let me get a D1 Mini, an old D1 Mini. Get this out of the way briefly. This is the microscope. I have a microscope view here and all the whistles and bells. Oh, let's actually do that one. And now we got all the stuff. Although you guys, the YouTubers that are watching on the phone probably cannot see the chat bar and everything. But this is an old Wemos D1 Mini, version 2.3, so it's much older than the one Gonad was using. I think it's down to whatever this thing is. A something or other. I can't read those letters. It's too small. Oh, there's a nice diode in there too. A little Schottky diode. That's nice of them. Oh, but it's after the power supply? Weird. AS something PK. I don't think it's any secret what components they're using. We could probably look up what that power supply is. What up, Smith Clay? How you doing? ESP runs on 3, yeah. So this, whatever this is, whatever this regulator is, the 3-volt regulator in here, is probably what was suspect. and bypassing the internal regulator and putting her own like LM1117 on the 3v3 line would have worked too. How's it going, Rambling Geek? Yeah, so this is an old school Wemos D1 Mini. These are really cheap. They're really easy to get. You can get knockoffs of them too. And they're really fun to use with something called WLED. WLED will run these addressable, well, it'll run a variety of different LED displays, but namely it does the addressable LEDs, and you can do all kinds of really cool control over your LED visuals with them. But apparently we've discovered as of yesterday that these things are a little bit moody when it comes to power. Yeah, W, LED. As WLED is one word. It was before everybody started labeling things W and L and E and D. Comes from my big box of tricks. I got a lot of microcontrollers in here, so we've had to do a variety of projects. One thing that I've been wanting to get into, but I haven't had time for yet, is the STM32s. They're apparently extremely powerful. They're super crazy powerful. And there's an Arduino core for them, so I can actually use them with a language that I'm super comfortable programming in. We have a drum pad. It's a MIDI pad that I want to fully hack, and we've partially almost fully hacked it. And it's sitting in the other room, and it just needs a little code time from me, a little time in the seat, just reprogramming them. What's that? STM32 is what bypasses the Dymo DRM. Gotta love the blue pill. Yeah, I think that was a blue pill that I just had. That's crazy. Bypassing DRM. The problem with the LED light strips is that they cost 2 to 3 times what the D1 Mini does. Yeah, the D1 Mini is like a $2 microcontroller. It has no business being as cheap as it is. Kind of like the Seed Studio Zhao. And it's like, why would I get a knockoff if the real thing's $2? There's some pretty crazy ones out there, though. Pretty crazy microcontrollers. What the? Yeah, this is not, we're not characterizing, if you've noticed, I'm not characterizing a filter right now, which means that we have not started stream. Try to keep up. And I'll usually piss about for, I don't know, sometimes it's up to an hour ahead of stream that I'll just sort of meander. But not a lot of people are doing this nowadays. I don't understand it. Like, if I sat down and turned on all the stream stuff and had everything ready to go and I just started, nobody would know what the hell's going on. And so this allows people to gather ahead of stream, and then when I start, I'll actually tell everybody what I'm doing, and then nobody has an excuse, except for people who tune in midway through, which is totally reasonable, because there's a lot of people that do that. Nobody's really sitting down with a pot of coffee and going, I'm gonna watch Bother start to finish today. I'm the only one who does that. I'm the only one who watches my own streams start to finish, because I'm doing them. I don't know what's going on after you start either. It doesn't help. Well, at least you know that stream has started. I hope Gonad realizes I can't reply to his messages because I'm freaking streaming right now. Oh, there he is. Now he's in the chat. I can't do Discord while streaming. It's like I'll stop talking and go, tap 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 on the keyboard. But Speedy and I were talking about that. This is less than 5 volts. It's just crazy. That's just insane. I was telling everybody about your problems a minute ago. Why would the D1 Mini need less than 5 volts? That's just baffling. I'll get it out again. I had a D1 Mini out, and we were looking at what the power supply is. And it's some SOT235 of some sort of nature. I can't really get the numbers. I have to zoom in a little bit more. My eyes are failing me. We're going to be working on Steve's MS-22, which is a Eurorack filter. That's this thing. Eurorack filter that I just finished assembling. A beast of a project to build. I think we did a little bit of the soldering on stream, but I did most of this off air because it was just monotonous, absolute insanity. I really kind of feel like throwing this thing into like a soldering oven so that all those resistors can even themselves out. Hand assembling is a little bit sloppy. Mine are definitely knockoffs. Yeah, so they're saving money on whatever power supply that is, and that's what's being so moody, I guess. I don't understand why the thing has the agency to even power up at all when it gets more than 5 volts. Like, why would it even, I don't even acknowledge. I mean, more than 5 volts, it should be totally fine with. One only works if I keep my finger on the antenna. I tricked it with a clamp. Oh, so is it like bad? Is it like cracked soldering underneath it or something? And these things are so cheap, I would expect to be finding problems like that all the time. But yeah, I was just looking at the power supply design. Apparently there's a diode in there too. I don't know what that diode is doing. It's a grounding diode, but then there's the MOV, current protection. It's just RF voodoo. Yeah, are you too close to the... I've heard people say this before. Most of the RF stuff, by the way, if you're an engineer and you're looking to get into RF, you're much smarter than basically everybody around you, and you're probably intolerable. But anyway, RF stuff is crazy, and most of the stuff you hear in terms of like RF technology are just things that you've heard from other people. So I've been told once that it's possible that it would have trouble connecting because it's too close to the router. My steak is too buttery. Why would too close to the router? Apparently it's like shouting at your router and it can't hear because it's not attenuated by distance, which doesn't make any sense to me, because if I'm shouting at somebody, they certainly can hear what I'm saying, but maybe I'm just a little too shouty and they can't make the words out. That may be akin to what was going on, possibly, but I don't think your router's in the same room. What's up, Bothan? Setting off. By the way, if you guys hear the occasional punctual fart noise, that's them. They're setting those off. That's actually a dollar store fart noise maker that I stuffed into this OtterBox, and they can spend channel points setting off either targeted or random farts. It can be one of 9 farts or just random. Might be worth revisiting this sometime to kind of clean up some of this 3D printing. Not that my printer is any better, it's the same as it was back then, but maybe I could make the text on that be a little bit better. But that's actually a thing here. I've got an interface with Twitch through Node-RED, and there's all kinds of stuff that gets control. I was gonna say, all kinds of stuff that chat can control. No, not anymore. Used to be, if you'd subscribe to my channel on Twitch, we'd put your name up on the board with a laser. That's coming back. We're going to get to that. It's actually using a Harman Kardon speaker, like the type of speaker that was in those clear Apple speakers that everybody loves. Those expensive clear Apple speakers. By the way, don't buy speaker hardware from the early 2000s because all the foam around the cones has just become soup. They're gone. Listen, maybe you'll stop asking about it, because every time you do, I put some extra time on the end. It's in 5 years, now it's 5.3 years. No, I'm not actually doing that. We have been working on it. It's been intermittent work, and there's been small improvements. It's just the unfun part is coming up, which would be tearing down all the wiring, doing maybe 1 or 2 preferential changes in the hardware, and then making a wiring harness and somehow believing that I can test that in any kind of a meaningful way. That's what's up to come with that. And dusting it off would be another one too. Yeah, ADHD brain. I'm not hyper fixed on Eurorack. I'm not losing sleep over it. Eurorack is like a series of project. It's not one thing that I'm working on. It's a bunch of little things that I'm working on. And I've been kind of hopping around and doing various, because it's you use the engineering brain to test it, you use the technician brain to build it, there's a physical end of it, and then there's a playing music end of it. There's a lot of variety in Eurorack, and it's been kind of a deep hole that I've gotten into. But Julian came before Burn the Subs. Julian has been after me for 20 years plus to build him a synthesizer, and so what this has done is it's taught me a lot of the stuff. It's taught me a lot of the types of analog and digital circuitry that kind of mash together in order to create synthesizer sounds. I'm not much of a musician. I've got a little bit of musician in me, only on the weekends. No, I've got a little bit of music in me, but I don't know how much. I don't know what kind of talent I have for that, and it'll take a little bit of work for me to actually be able to play these things in any kind of a meaningful way. But it's been something that I've wanted to do and I've been obligated to do for many, many, many years. So that's why I'm putting such effort into it now, and why Burn the Subs is taking kind of a backseat for a little bit. I was at the end run of my old house for cable internet, sorry, and my modem kept dropping in and out. 3 people came and looked at it before they finally sent out a proper engineer. Turns out the modem was getting a big stinky dB from the amplifier being at the end of the run. They need to drop down 10 decibel to make it stable. The modem was in fact being yelled at, and it was confused and scared. Interesting. So all of the RF was mashing into the end of the run and being indecipherable as a result. Some weird stuff with RF, I'll tell you what. I can't believe that the D1 Mini was such a jerk about power, but I guess that's knockoffs, huh? All right. So I think we need to get to characterizing some filters here. We need to do some Walter. We need to do some filters. Let's get this out of here. Let's get the music out of here. How do I do that again? Do this. Woo! There it goes. It's gone. Okay. And then get rid of this, and we're good to go. Hey, what's up, everybody? So, YouTube has kind of like activated something for me, and I'm not saying no, but it wasn't very consensual. I'm not saying no to it, but they are doing a vertical window for the preview. So I guess we're also vertical, which means we will get some key jingling people in here. It'll be funny. We'll see what happens, but it should be interesting if we reach a slightly wider audience with that. Oh, we'll see. I don't know. I don't know if I'm built for this. Right now, my video preview is off the window, and they're just looking at the center of this, which not a lot is really happening there. Maybe I'll try to keep my keys jingling a little bit. But what we're working on today is a continuation of all of the Euro rack building that I've done over the past umpteen years. It's been like a couple years now. I'm trying to build filters because my buddy Julian, who is Zelikovic Music, he's one of the producers of Radioactive Sandwich, and I've known him my whole life. And we've been doing weird stuff for many, many years. He's finally convinced me to learn and build modular Euro rack stuff. I'm good with digital electronics and system integration and the stuff you see that's not musical around here. And I was thinking it would be kind of cool to like be able to make funky noises ahead of stream to just kind of fill the air instead of using music, which is getting, copyrighted and stuff all the time. So my thought was, okay, let's do some Euro rack stuff. And I've spent quite a bit of time embroiled in Euro rack things, right? To the point where we've even made our own circuit boards for stuff. And I still need to order the powered multi board with all the corrections on it, the one that'll actually work now. Vertical video live stream title. You won't believe the rack that I'm looking at. Oh, geez. I don't want the people that will click on stuff like that here. You have to realize you have to curate your audience a little bit on these platforms. Otherwise, it's going to be a shit show. I probably shouldn't have said a curse word because now all the moms are reaching for the iPad to throw it across the room. Instead of watching this boring guy talk about boring stuff. Anyway, hi. So I've been working on Eurorack stuff, and I've been giving it my full attention in order to make these things the best that they can be. And we're getting to a point where I'm going to actually get to the point where we're no longer doing the electrical stuff on this, and we can work on other projects. And I want to get all of this stuff working so that I can have the musical setup on the side, and yeah, so we can focus back on things like Burn the Subs. But with all that we've learned from modular synthesizers, which is quite a lot. It's actually quite a lot. A lot about servos and moving waveforms and stuff like that. But what I'm working on specifically right now is Steve's MS-22. There's something called the MS-20, and apparently this is based on that. But from what I know, it's just a good filter that I've gotten some Growth at any cost, yes. And not even just growth, it's rate of change of growth. The rate of change of growth must always go up. Anyway, so you build these filters, but they're filters. Filters are complicated. Filters have a lot of math behind them. Filters have feedback, and when you have feedback, you have stabilization. You can make a Bode plot. You can do all this cool stuff. We're going to do a little bit of that, but what we're going to be doing is fast Fourier transform. If you have a waveform and you display it on a scope, you're displaying it as volts over time. And actually, quite literally, it used to be that you would have something that would scan an electron beam across a tube with phosphor on the front. And the phosphor glows, and it has a little bit of persistence of glowing. And so when you scan that a lot, your waveform will topple over itself and sort of reinforce itself. And so in a classic scope, you have magnets that are moving an electron beam, and those magnets are being electrically controlled at a scale based on whatever voltage you're giving it. So you scan over time, and you would tune that time in order to make a coherent view so the waveform would properly run over itself. You used to have to tune that yourself. And so you'll get something that looks like a nice sine wave, but it's actually the voltage going over itself again and again and again, making that persistence. With multiple different frequencies on the same waveform, they concatenate with each other. They sort of boost each other and damp each other according to, you know, the difference in voltage of your two waveforms. When your two waveforms mix, it can make kind of a really messy display. What you can do is, using some special math that actually a research paper reinvented. It's the chemists reinvented Fourier transforms. It's a magical thing about finding the area under the curve. You can characterize all of these different frequencies by doing what's called a fast Fourier transform. The fast Fourier transform displays not volts over time. It can display volts, but you're typically doing decibels. But you're displaying all the frequencies on one axis and then your levels on another. So if you have a frequency that gets quieter and softer, then your Fourier transform is going to have a bump that gets bigger and smaller, right? At that frequency point. So that's what we're going to be looking at, because these are filters. These have responses to frequencies. And so we need to characterize that so that we can tune it so that our adjustment windows are all in the right place. And Steve's MS-22 has really been kind of kicking my butt. Cody's Lab's way of figuring out area under the curve is just cut it out and weigh the bit of paper. It's actually really good. I mean, it's the right thing. Yeah, there was some paper where some chemists were like, how do we find the area under the curve? We've invented a totally new way to do it. And it was like the beginnings of fast Fourier transform, and all the engineers were like, wait a minute, we know what to do. It's really close to the actual right answer. I think I remember that from back in the day. So yeah, Steve's MS-22 is this crazy build. It's been multiple layers of circuit boards, and they were originally all laid out flat. I had to order parts that were really, like, these were really expensive, these switches. But what this is two filters. And so it's a low pass filter and a high pass filter. Well, what does that bother? What does that mean? What does low pass and high pass mean? Low pass and high pass filter. You are allowing low frequencies to pass, or you are allowing high frequencies to pass. So you've got two ends of your frequency spectrum, and we are damping one or the other, depending on what we choose. And that can have all kinds of effects on your audio. It can make things sound really cool. You can have cool cutoffs and stuff like that. It's just very good stuff. I've had my ear chewed off about fast Fourier transforms this whole month. A buddy of mine just made an open source tuner webpage because he couldn't find a tuner app for his iPhone without ads. I wonder which one Julian is using, because he has a tuner app that he uses in order to do like shows and stuff. I should ask him which one he uses. I don't think he uses iPhone though. Does he? I don't remember. But yeah, that's one of those. All right, so yeah, FFTs. Now I could inject noise. I can inject noise into the system and then characterize that with a fast Fourier transform pretty easily, but I think Kinks is putting out kind of a weird sort of noise. It's more like a control signal noise. It is impossible to build a fart filter though, because they can fail. Oh, farts can fall into many frequency ranges, yes. We're injecting noise. Where are they? I don't hear them. Oh, well, right on time. All right, so what I've done is I've taken my module testing module and I'm using it as a power supply. Actually, wait, we're not done with Steve. Steve's MS-22. High pass, or no, low pass, high pass, I think. Then it has resonance, which is feeding back into your loop. The resonance has a certain level that it kicks off at, and it's been far too violent lately. I don't know what's going on with the resonance on this thing. We will have to re-explore that. We have their overall filter gain as the next adjustment, and then we have two knobs that we don't have labels for. What these knobs are for is you can have two control signals going into this filter. One of them goes through this knob, sort of, and controls frequency. I think, yeah, it controls the high pass frequency. Yeah, frequency per volt. And then the other one, Jesus Christ, you guys. The other control voltage goes in and you can assign it to the controls that you want to control. So you have a plus and a minus here for positive or negative control per the control voltage. So this is very modular synthesizer-y. It's basically, if I want to control something, here, let's flip this on and I can show you guys the lights going on. Steve's MS-22 does a cool thing. It uses an extra set of comparators in order to show you where your knob is located, even though you can probably just see the mark on the knob, but it'll show you what's going on, where it's being controlled. And so if I actually take one of my triangle wave signals out of this thing and I put that in to the control thing, nothing happens, right? Until I select to control this, and now, and now, there it goes. Is this working? It might not be working. Yeah, maybe my triangle wave isn't quite doing it. Well, this one does high, low, and low, high, but I don't think that one functions very well. My module testing module has been breaking. More like module, broken module. Well, I've seen it work before. It just refuses to work right now. That should be going up and down very slowly. Oh, there it goes. That's hard to see. Hard to see. Anyway, yeah, we have bigger fish to fry than fixing my stuff. Hold on, let's put the scope on. And we can take a look at this. Yeah, there we go. Yeah, it is doing triangle wave stuff. So the big question when you're done building something like this is whether or not you've soldered everything correctly. And I think I have. I've been over the soldering several times on this thing, desperately trying to get any kind of, functionality out of it. I did plug it in wrong at one point. I had two little pins sticking over the edge on the header down here, but everybody is TL074s and LM39. Well, no, that's not in this one. They're TL074s, which are pretty robust. And LM3700s, which are also pretty survivable to any kind of little mistakes. So with any luck, I haven't blown anything up. It took me a little while to find headers for everybody here because apparently I've used up all of my small headers. But yeah, so everything should be well and functioning. The only problem is we need to tune the operational window for the controls on this thing. So, how's the barfometer looking? I don't know about any barfometer. I'm feeling fine, if you mean my own personal barfometer. Okay, so let's hit this thing with some frequencies then. We've got the thing powered up. I've got my in and my out plugged in here, but we don't have any source for the in. The source for the in is coming from my handy dandy trusty frequency generator. This is a, I don't know, FG085's little kit that you put together. Had all the surface mount stuff already soldered, and then I sort of put the rest together. It was real cheap back in the day. I think it's probably gone up in price just because of electronics availability, and then smartly it has all of these wonderful capacitors sticking out the back that you can just Break off. Oh, there's an ad break going on now. God damn it. God damn it, Twitch. Twitch, you freaking fricks. I have mid-roll ads in order to improve our discoverability. Bother. How's it going? We got an ad break going on right now, so I can stop gushing about my signal generator. Anyway, I bought this thing as a kit, and this thing has been super useful. It takes like a 9-volt in, and it's able to do the positive and the negative waveforms. So in reference to its own ground, it's kind of neat. I've had good luck with this one, although a professional waveform generator would be nice. I have one, and it needs to be tuned, and that's apparently like a huge hassle. So maybe one day I'll afford like an $800 Rigol waveform generator, or I could potentially build the waveform generator that goes in my scope. Apparently my scope is like super hackable. We can make that into a much better scope somehow. And I've got all the information about how to do it over here. It's just, yeah, we're gonna do it. All of Twitch's ad breaks at this point. I hate it. I hate it. I guess I'm of a time now when Twitch did not have ad breaks, and you would support the creator yourself. Unlike YouTube, where the ads are actually paying the creator, having no ads and paying the creator yourself. I like that compromise. I think that was great. I'm now not getting ads on Twitch, not complaining, but it's weird not to. Are you set in a location that doesn't have ads, like Ghana or whatever? There's some locations that just don't have ads. And then there's also plugins through ad block scripts that you can run to kind of tamp away the ads, which that's what I do. So we are running a sweep right now, a frequency sweep that's going to allow us to characterize the frequency response of the filter. I'll try to actually show these things on camera. Getting a little busy on screen here, but oh yeah, the people who are watching in a vertical format are missing out on thermal imagery. So start sine wave 10 hertz, end sine wave 30K, 30 kilohertz, 5,000 milliseconds sweep time, 1 millisecond step time. Those are the settings. And I've tuned it to plus minus 5 volts. So you can see there in the yellow trace, man, this is a long ad block. How long is this one going? We'll be done in just a sec. So I'm going a little bit below and a little bit above the range of your typical like speaker and audio equipment, which is, a little bit below. It's really 20 hertz to 20,000 is where you could primary. All right, ad break's over. Welcome back, everybody. So we're sweeping a frequency. We're sweeping a sine wave from a little bit below 20 hertz to a little bit above 20 kilohertz. And so what that looks like is the yellow trace right here. That's the sound going into our stuff. I have it plugged in with a BNC cable. So the BNC cable plugs into the frequency generator. The frequency generator goes over to a T-splitter, a BNC T-splitter, and then I have these BNC to headphone jack adapters. These things are really nice if you're doing modular. If you're building your own modular stuff, getting a pair of these will save you so much aggravation. It's amazing. In US on my phone using the app. Huh. I wonder why. I wonder why you wouldn't get ads. Well, yeah, hope you just stay under the radar. So Steve's MS-22 uses a lot of op-amp circuits and a lot of LM1117 shenanigans in order to filter, in order to have a high pass into a low pass filter. The topography of the filter is complicated. There is no schematic. There's no schematic for this. So my individual poking about is not really happening. And there's all these test points on the back that I don't know what they do. Now, Steve, if it is Steve, I'm just going to refer to him. I'll call them Steve. I think there's multiple blokes, but they don't want to distribute a schematic to get copied, so they don't post it up online. You can ask them and they will send you a schematic, but I am an introvert and I have not asked them for a schematic. I don't know if we'll need it necessarily. Hopefully not, but these are getting kind of annoying to tune. We have the span and the gain for both filter stages, and it's getting a little difficult to tune. So what I've got going on here is the waveform on one side and then the fast Fourier transfer on the other. But the thing about the fast Fourier transfer is typically, if I can pull up the menu here, typically it doesn't persist on these scopes, and it's a little bit slow. It does all the calculation in real time, and it does it for like 10,000 points. And I think I can dial back the memory on this a little bit, and it'll get faster at doing what it does. But supposedly we are supposed to be displaying from a little bit below to a little bit above. So we're displaying the full range of frequencies here from 15 to 30K, yeah. 15K to 30K, it keeps changing these things. This should be 10K, or sorry, 10 hertz. 10 hertz all the way up to 20 kilohertz. Now it's doing 10 to 20 hertz. What do you... 20K. Then it changed the other one to 10K. Why are you being such a jerk? It's like we should see a little bumpus going across here. If I do, let's just put that into the mult. The powered mult. Put that into the mult. Why isn't the mult lighting up? Oh, there it goes. Okay. And put that output into that right there. What? Oh, it's not fully plugged in. There. So now our two channels are exactly the same, and you can see the little bumpus go across there. I'm just putting them both into something that one for one replicates the frequency. So as this thing gets quieter and louder, we see a difference in the shape of that bump and the size of that bump. And all the units are crazy. This thing really should be a much wider spread. I don't know why I have to like fight my scope. Maybe if we zoom out a little bit on it. Just zoom way out and then take a look and see whether or not this thing can go from not 10 kilohertz, 10 hertz. I want audio spectrum, but it seems like I can do 10 to 20, but I can't do... Why would it do this? Handing window, channel 2, operations on. I thought I had it on the full. So if I set it to max, 625 megahertz. So if I set it, you fucker, 20 or no 30 kilohertz. I actually want 30K. Oops, no, 30. Sorry, I'm using a touch screen right now. 30K. It resets this one. What's the minimum? 5. But if it sets it to 5, then yeah. 5 hertz to 10 hertz. That's not useful. How do I up your resolution on that? The offset is the vertical. I'm talking about the horizontal. Man, this is annoying. Struggling with my scope. What are you guys saying? Calibrate it with the sound of farts. Recommendation is to use white noise for calibration. Yeah, but I don't have a white noise source. I don't think Kinks is putting out the right kind of noise. So, I mean, I could use the noise output from Kinks. Right now I'm just struggling with my scope today. I thought I had this thing going from 10 to 10K, and that was the display that I just had up when we started the stream. But now it's being a jerk and telling me that I can't do that properly. What if we zoom way in on the waveform? Whoa. Wrong control. Zoom way in. So now we're way in here. What can you Fourier? Oh, start to end. Oh, that's what was happening. That was span center. Oh, I was in the wrong one. So yeah, we're starting at 10 hertz. You guys can see me manipulate this on the thing. I'm actually over here poking this screen with my thumb. You can plug a mouse into this scope. You can put a mouse and keyboard on this thing. It's just a computer. Like, pretty cool, right? 10 hertz. No, not 0. I specifically requested 10 hertz. What? Oh, because it's 10 hertz over here. It's not letting me do it. Okay, so this one is 30K. 30 kilohertz. This one is 10 microhertz. Okay, 10 hertz to 30K. Okay, now my settings are actually staying in there. So now we can see the full spread of, why does it look bad? Why does it look wrong? Why does it look bad? Do I need to zoom out on this? Oh. What? Okay. 10 hertz, 30 kilohertz, start to finish. Start to end, dBV. No color grading yet. We'll do that in just a second. No labels. Okay, I think that's all set up. I don't know why the frequency display is looking a little weird to me. Yeah, because it's going from 3K. Why isn't it displaying the full range that I've actually set it for here? Math 1 is doing that operator, and this window is Math 1. Why isn't my window scaling? What the what else do we have? Peak numbers, 5. What? Oh, we're peak searching. Amp order, frequency order, operations, FFT. Why is my window not displaying the whole thing? Because we're in start end. How do I make it display everything? Hurts, don't it? Yes, it's very painful. What controls do I have over this thing? I could close the window and open it again, because it's like, I can't pinch zoom, and then this is just scroll back and forth. It's like everything's gone on the screen. What the I'm closing this, and I'm gonna do measure. Oh no, not measure. Analyze? No. Math. Operation. Source channel 2. FFT. Nope, that's Math 4. Back to Math 1. Math 1, FFT, all that stuff. How do I, turn it on? There we go. And yet it still decides to truncate the window and not give me the full display. I watched a whole video on how to use the scope so that I could learn how to do this stuff. And for some reason, this thing is completely destroying my ability to view what's going on. I'm trying to figure out how I can get the full range back, because I had it displaying the full range of frequencies. It just doesn't seem to enjoy doing that. Maybe it is, maybe that is what it's doing. Yeah, I guess it's the scale is weird. The horizontal scale is not logarithmic, because it goes from 2, 8, 13, 18, 24. So I guess maybe that is what is. But it seems like it doesn't have a lot of resolution. Let's try a different window. The different types of fast Fourier transform equations. Let's move that down a little bit. There we go. Yeah, I don't know. We'll go back to Hanning window and actually do the frequency sweep. So Hamming window. Hamming window looks a little bit closer to what we should actually be seeing, but I don't know why. Like, the span of that bump is way too huge. That's enormous. But I guess if this is all the display, if this is showing us, in fact, from 50 all the way, or from 10 all the way to 30, then it should be okay. My coffee should be done dripping. So anyway, this we can see it's just a flat line right across the whole thing, right? Because we're not actually filtering anything right now. This is literally just displaying, this is just repeating whatever we're putting into it. And it's doing a pretty decent job. I mean, through the whole range of audio spectrum, we're getting a nice big signal back. We're not getting any signal degradation at all. If I were to analyze this a little bit more closely and see what the window of this filter is, I actually, and there's no like clear, easy way to hit the reset on this, but what I can do is turn on color grading, and that's going to add persistence to the scope. And when you add persistence, that actually will build up. I don't care about the color grading, right? It's the scope's just doing the color grading on its own. What I'm interested in is what this thing is seeing as a frequency response as per the input. So what we're actually getting here is the window of the filter. The window of the filter is wide open. Everything is completely open. There's no high or low frequency filtering going on through the range of the frequency sweep that we're doing with this little guy right here. So this will tell me what the response of the filter is. Now, Steve's MS-22, we need to actually use that in order to test this filter. So the other method that I have for doing the noise would be if I plugged in Kinks. The Kinks module has a noise output that looks like that. And so if I actually run that for a frequency sweep, what kind of noise are we going to see coming out of Kinks? I'm just curious about this. So, I mean, it's roughly the same, but it's not quite as controlled. There's peaks and valleys to the frequencies that it's analyzing. And I don't know what particular type of noise is. When you mix a bunch of frequencies together, you get different types of noise. This is actually being produced by a transistor, sort of unstably vibrating against itself. Don't try to explain persistence to chat. Most of us don't even have object permanence. Jingle the keys, jingle the keys, jingle the keys. Look at the cool waveforms. I mean, that noise is looking pretty decent when we put up the persistence of the scope. Persistence of the scope is just you're viewing the glow stick trails more, and you just keep them up, and they'll give you sort of a, you know, an idea of what's up there. What's up, Mahalo? You got a golden kappa? Where did you get that? Has that been on the ground? Don't. What are you doing? What are you doing with that? Okay, let's get this out of here. So, turn persistence off for now. Because yeah, with white noise, we don't necessarily see like all of the frequencies cohesively go up, because it's not all the frequencies there in that noise. It's just a chaotic waveform. But we see generally sort of a flat line for all of that. But I prefer to do the frequency sweep. I think it's a little bit more controlled. Okay, so our output goes to the scope. Our input, which is displayed there on the waveform, comes from here. And so Steve's MS-22 is now firing along at all cylinders. However, I have messed with this thing so much. I licked it to make it extra shiny. Oh no. Well, at least gold is pretty inert. So I have Steve's MS-22 doing its thing right now. And if we play with the resonance knob, this thing will very violently go crazy and explode. What is going on with that? I had this thing mostly working, and then I had it mostly not working. Something happened to it, and it no longer worked right. So what I need to do is return to a baseline. So before we do this frequency sweeping, let's actually set these four potentiometers to their regular value. Let's see what they do. Let's take a look at the manual real quick. So down here in the manual, they got all kinds of things to do. One of them is how to tune this filter. And what we're looking at, by the way, the filter topologies are crazy in this thing. I really would rather look at a schematic to know what's going on, but they give you, this is like the most detail that they'll give you for the actual topology of the whole thing. What I mean by topology is what's connected to what, where. What order of things are we going through, right? So all the way down here, we start to see appendix, calibration. The goal of calibrating the modules to map the musically useful ranges of the high pass and the low pass filters to the physical range of the respective knobs. Why are you guys looking at me? I'm not the knob. Stop looking at, no, that's not. I've illustrated what a proper mapping looks like in the drawing below. So for the low pass filter, fully attenuates low bass all the way there. There's a small zone of non-audible. That's not a V, that's a U. Cursed these handwriting fonts. That is a V. You need to work on your handwriting. I prefer bottomology. I know a few channels you could find for that. Anyway, fully attenuates with low bass note, and then when you turn it all the way to the right, you should hear the low pass cut into the noise. I don't know what that means. Hear the low pass cut into the noise. For the high pass filter, fully passes the low bass note all the way at the left. You turn it to the right, you should hear the high pass resonance starting to affect the sound at the output. I don't really know what that means, but I have seen it on the scope. So calibration setup consists of sending a white noise source into the MS-22 and then using a spectrum analyzer to look at the output. The resulting live spectrograph is then used as visual feedback to trim the ranges of the low pass and high pass so that they're mapped to the full range of the audio spectrum, 10 hertz to 20 kilohertz. To calibrate the module, we need to build a setup using the digital audio workstation Ableton. I'm not using Ableton. I'm in fact going to be using my scope, because my scope does all this stuff, for better or for worse. I just don't have access to Ableton right now, so wait a minute. I actually do have Ableton installed on this computer. We're not going to use Ableton. We're going to use my own thing. So here are the adjustments. So for high pass and low pass, and the filter itself on the front panel has, where is that picture of it? I think there's a picture down here. So the knobs that I'm looking at are low pass, then high pass. And for this configuration, I've got gain in the middle, resonance is just before it goes unstable, and then high pass and low pass are at those two ends. So if I do high pass this way, low pass this way, the problem is it's kind of quiet on the output. Like, that's really quiet. We're piping it in through BNCs, so it's not like I accidentally hit the times 10. And so we're looking for stuff that looks like this. And it basically it'll look like kitty ears when we've got it configured properly, right? All right, let's try to get a sweep done. Well, actually, here's the thing. I have messed with this enough that I got frustrated and I started to really wrench on the knobs. So what we need to do is we need to actually set these trimmers to be specific resistances. We need to set them back home. And these potentiometers don't give you like a click when you get too far in either direction. So I need to reset these with the multimeter. With the multimeter, which I've done before. I guess I'll do it again. I wish I knew where the test points were on the back, because I think that would be an easier way to get that value, but we can just get it from doing a little bit of multimetering. Multimetering. What's going on, everybody? I'm back. I was gone for a little while. Had to get to appointments and stuff in the city, so I wasn't in any reasonable position to get back to stream on time. So I had to skip on Tuesday. I don't like doing that because then it's like a full 6 days before I stream again, which is crazy. I may need to pick up more days streaming. All right, so that's at 1 ohm, and that's the gain trimmer. The gain trimmers are the ones that are closer to the edge of the board. So we're at 1 ohm, so we need to be at 3.7 to 3.9 as a starting point. So I go in a direction. I think I should be viewing from over here would probably be better. Go in a direction. So that's right hand. Where's my probe? There's my probe. Now we're at half a K. So I just did 500 ohms by doing that. So 500 becomes 1K, becomes 1.5K, becomes 2K, becomes 2.5K, becomes 3K. Let's see if that did it. We're looking for 3.8. $32M. That doesn't seem right. Damn it, I slipped. Okay, hold on. I gotta get better grip. Better grip. Oh, you guys wandered. Multi-pass. Negative, I am a meat popsicle. What's going on here? Give me that value. 511 ohms. What? Was I measuring on the wrong side? If I go this way. Or did I loop it around? Some of these loop around. The ones that I like make a little clicking noise when you get to the extreme. Yeah, we're now at 1.8, so this one's pretty sensitive. I'm wondering if I looped around or if I went the right direction there. No, now I'm actually going the right direction. .6. Did that go down? Three. Okay, so now we need to add 800 ohms. And this will get us to a starting point where we can actually see these adjustments affecting the frequencies that we get back. But we're going to have to do that at the speed of sweep instead of doing it at the speed of a good white noise source. Because I don't think Kinks is putting out the right stuff, and it's much more recognizable when we do the frequency sweep, because the scope has time to like take a good look at the waveform. The fast Fourier transform coming from the scope is a really cool thing. It turns your scope into sort of a slightly less capable frequency spectrum analyzer. Pretty useful stuff. I saw somebody had an app that you could run from Python 3, and it would get into the scope through the Wi-Fi and do a full Bode plot, so you could really characterize your filter and the frequency stability of it. I thought that was really cool. Way over the top. I don't need to do a Bode plot for my synthesizer stuff, although it would be appropriate to do. Come on, where is it? Tell me. We should be right on the dot here. 3.8. Come on. Ugh, stupid thing. Thing sucks. Play us out. What does that mean? 3.7. That's in spec. 3.73 is close enough. Let's go to the next one. So this one's also gain plot. So we're looking for 3.7 out of this. No, come on. .36. What the? Okay, hold on. I gotta get in here, get my probe all the way to this pad back here. 4.8. So we're going down. Down, diggity down. Doot, doot, doot. That should get us in 3 point something, something, something. What? Wait, it didn't move at all. What happened? Ugh, finger slipped. On the later designs of this one, this filter, they actually use normal scientific trim pots, the blue ones that are much easier to source and use, which I appreciate very greatly. They make crunchy noises if you hit them hard enough. Yes, true. What's up, Swizzle? Swizzle, swizzle, swizzle circuits, swizzle, 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 swizzle. God damn it. I can't get this thing to stick. This is why test points are nice. Okay, 3.4. So I overshot it a little bit. Just come back here like that. 3.6. It's going to be like 3.9. 4. You just come in here and you just set off fart noises. And that's it. That's all I get. 3.9. We go down just a little bit. So that's gain. Oh, a little bit more. Break down, break down. Okay, there. That's right in spec. 3.7. All right, now for the next ones. Now these have to be set to 13. Well, 14K is kind of the goal here. Give us more toys. Yeah, the money gun is something that I do need to work on. Money plane. Yeah, the money gun is one of the funnier ones, but that one puts me in danger of actually making money and then ruining my health insurance with that. So I gotta be careful about that one. Okay, so we're looking for 14. That one was actually pretty close to 14K, wasn't it? 13K. So we're going to go this way. Is that moving it up or down? Oh, it's moving it up. We hear thunder. By the way, if my power goes out, that's the end of stream for the day. So we've had a couple thunderstorms kind of rolling through. 13.4. Looking for 14. Okay, that's good enough. We're leaving it right there. 14 and a half is right in spec. This is the kind of stuff that I've been doing yesterday. Very, very annoying to adjust this. But once we get it, it'll be good. I wonder what the factory does to tune these. You're not exactly going to set everybody up. Well, I guess they do the proper thing with Ableton and a spectrum analyzer. 5K, so we need to go way up on that one. This is what I mean. I got frustrated and I was just like sweeping the knobs back and forth to try to get anything to happen, and it just wouldn't. So I have a feeling, I have a sneaking suspicion that there is some kind of a physical problem still with the board. But I think like, if you're getting audio out of something like, 1.6? If you're getting audio out of something like this, it's probably mostly working then. $12. I need 14. I feel like this one's adjusting in the opposite direction of the other one. 14.2. So we just go and give it just a little tweak back. I want it to be at 14. Okay, that's good enough. I mean, my scope's probably off by a little bit too. Twisting your knobs. Yeah, twisting my knobs. It really twists my knobs. Okay. Ow. Ow. These things hurt like hell. These are high voltage probes. They're designed to keep you far away from the high voltage thingy, but I use them because they are extraordinarily sharp and long, and so they can reach into stuff and they can poke through solder mask. All right, back over to here. How's it going, Hedonica? Okay. Hey, Hedonica. Hey, how you doing? God, sometimes not everybody in America has, you know, the cowboy accents. I certainly don't. I'm from the Northeast. But every now and then, hey, howdy, rootin' tootin'. Shut up. All right, so signal in. How much that fluke was? I think 120 bucks. But I bought the fluke from eBay. Because fluke multimeters, you can drop them down a flight of stairs and they still function just fine. And so my previous meter, my Fluke 179, broke. I don't know why it just stopped working one day. One day, like a stray like muon came in from outer space and just went bink and hit like one bit in the microcontroller, and the meter went and then died. So I had a dead meter with a really nice case, and so I went on eBay and I found one that had been in a fire. It had been in a fire, it was all melted, and I moved the internals over to my old case and works now. It's a little bit off. I had to buy this it's like a meter tester component from like the 60s that makes like 1,000 volts and you can like test all of your like sensitive equipment on. I got that and I did a little bit of tuning on it. I didn't do much. It's off by like a tiny bit. So yeah, that's my Fluke 179. But the thing about the 179 is that I can throw it in my like car tools and it will still be fine. It can you know, wrestle with wrenches and screwdrivers and stuff, and it will still function perfectly. So buy a bunch of cheap cables and fry me amp. Okay, so now that we've got the initial tuning in place, I can bring back the scope and we can actually observe, I'm going to turn the power on for all this stuff. We can actually observe this thing filtering, which it is decidedly not doing. There's no signal coming out. What's going on? Yeah, it's a genuine Fluke 179 direct from Fluke is $525. It's not $525 in technology. It's $525 in the calibration and the fact that it will survive everything you can throw at it. But yeah, this is the old, I don't know what's going on here. I don't know what that's about. That's getting a little manky. There's like no features on this. Like it only does certain things. It's technically, the beeper's broken, but that's the meter that I use. Boy, howdy, are there better choices out there nowadays. I suggest buying direct from Fluke. What, are you made out of money? Like, no, don't buy a 179 if you're buying directly from Fluke. I ain't made out of money, shit. Channel 3 we don't have. That is channel 2, and we are at 6 volts for our peak to peak. Why is the filter now not doing anything? Well, probably because of where I have the knobs. Like if I mess with resonance, yeah, it'll suddenly blow up. That's bad. That's like blow up stuff bad. I don't know why resonance is like that. It's a really bad knob. And then for some reason, we're not getting any gain out of the damn thing. But I guess maybe we're filtering. Yeah, we're filtering everybody out. So we let low and high pass back in. And now we've got stuff, but the gain is like, oh, actually, wow, now there's actually a lot of gain. Look at that. And it's cutting off a little bit. But now we at least have meaningful... Wait, did it make boobies? It made boobies over here. We got boobies on our spectrum analysis. One thing I don't understand is why there's so few points on this spectrum analysis. I used to get a really nice full spread of frequencies here out of this thing. Okay, so let's just, I guess, start from the beginning, right? Mitutoyo is really good for calipers. Those are the calipers that I buy, genuine Mitutoyos. So I've got the gain all the way up, which is fine. We are adjusting gain. I do not have any resonance on there, but if I bring it in a little bit, we can see, yeah, there it blows it up. Actually, it's not doing anything. Huh. Interesting. Okay, so we can see it. The output filter is getting quiet and loud, depending. The first thing this goes through, hold on. Glitches, blah, blah, blah. Yeah, this is what we just did. We just measured from those two pads. I hear thunder in the distance. Ah, thunder. So here's the various, like, oh, you guys are having trouble seeing this. Hold on. I know I have a lot going on the screen right now, but that's the whole point of it. Yeah, we'll just keep it secret from the vertical video viewers. I'll put it like here. There, that's a little better. Their sidebar is taking up a lot of the page, and we don't need to see all the Google stuff. I just need yeah, information here. It's coupling to the mic line. I can hear it. Let me keep myself off of ground then, because yeah, it shouldn't be audible, but there's a lot of noise in all of my systems here, so it could even be showing up through the power supply for all we know. So what we're doing is we're trying to expand the gain. The range of the filters is not yet properly matched to the physical range of the knobs to fix this. So first we need to do the gains. High pass and low pass cutoff. Important note, high pass filters are in series. We observe their product as illustrated in the figure below. So we're observing their product of the high pass and the low pass filters. So if I'm doing this correctly, we should see like a window, and then as I cut off the frequencies, let's just see if we see what they see. I'm going to adjust the gains a little bit here so that we get a clean input, because you can see it's clipping at the bottom there, and that's going to affect what frequencies we see. And then I don't know if something is wrong with my fast Fourier window or not. It seems to be going up to kilohertz very rapidly, and I guess it's probably not that logarithmic. I don't know, but one thing at a time. So let's take a look at the gains and see if we can tune out some of that clipping that's going on, because right now both filters are completely open. So I don't know which to start with. What's the first filter that we go through? I think it's high pass and then low pass. Or is it low then high? Where's our little topology thing? It's like way at the beginning. It's a big manual. There's a lot to get through here. So in order of, yeah, they say frequency spread, but it's actually low pass, high pass. Well, okay. Different from most MS-20 inspired filters, contains 2 dedicated filter circuits instead of one. One low pass, the other's a high pass. These are configured to be in series. The low pass goes into the high pass. There we go. Okay. Duophonic fighting resonance behavior. Okay, so it's low then high. And the order of the knobs is, I think it's low then high on the front panel. Yeah, low then high. So our low pass is all the way up and our high pass is all the way down. So let's start by adjusting a little bit of the gain of the low pass filter, which is in the middle. The high pass is on the end. I got to keep track of all these things all at once to try to get this thing to look like what it should. So the first one is the inboard one. And so that'll be our first gain to look at and see if I can't contain it. Yeah, see, there it goes. But our gain is set all the way up, so it really, like, why is it like that? That's weird. What happens if I... Well, that second clipping is really strange to me. Like, why is it... Look at that. It's enormous there. It's got, like, a huge amount of gain for the low frequencies, and then it... Okay, so what is that going to look like? I mean, as I adjust, like, if we do a low pass, and I close the low pass part of it, my output frequency isn't changing. I saw some little side fumbles there. What if we do the high pass all the way down? Yeah, no high pass filter means nothing coming out. So that's adjusting where the high pass filter starts. So if I adjust for the high pass, or sorry, the low pass, that's the low pass. But then where's the... So I'm going from 10 hertz to 30 kilohertz. Is this thing capable of getting up to that frequency? Maybe that's what we're looking at here. Is it not, perhaps it's not getting all the way up to 30K. But then, See, that brings it back, but it's like at the super high frequencies, it's like freaking out. It's going crazy. Let me just take a look at what the spectrum looks like, I guess. We'll do persistence on the fast Fourier transfer, and that should get us to look a little bit more like what the manual is trying to display. But what I don't understand is why we are... It's louder for some of those. Yeah, side fumbling of the lunar wane shaft. Reciprocating marsupials. Yeah, that's not looking quite right. I mean, the frequency response is flat. It's just, I don't know why. This is why I think something is wrong. I think something is physically wrong because of the responses that I'm getting here. Because they're saying it should look something like this. And I was able to actually observe some of this behavior before, but with the frequency sweep, I don't know. What if we did use noise? Let's go back to using noise. So let me get kinks. And I will pump kinks into... We're not going to be able to observe it except on the output. So we'll just take kinks here. Use that as a source. So now we've got noise coming in, and we can turn off channel 1. so now we just got noise, and I'm going to reset the spectrum. Oh, it could be that we actually need to zoom out a little bit too. Oops, no, not label. Reset that. Yeah, see, there's the noise coming in, and that's creating a... We've sort of got a downward-facing slope, which the frequency sweep didn't show at all. But it seems like with the noise, we can observe that it's cutting off badly, and we're out of spec. So that's at least something observable that I can now adjust against. Screwdriver right here. Okay. So yeah, let's see, gain on the low and high pass, so that those frequencies aren't clipping like that. Well, that pulled us into center line, but it's also... No, yeah, we definitely want that gain to be there. Oof, okay, so there's our full spread. There we go, okay. So like plus minus 6 volts-ish. We just bring these into one another. Oh, okay, so there it starts to... You saw it start to cut off at the negative voltages. So that's where we see that. And then if I mess with this a little bit more, it gets cleaner, which I don't know if that's really the goal here. See how I'm pulling in, we're sort of losing some of the higher frequencies in there, supposedly. I got a cool looking spectrograph going on over here. So let's reset that and see what it looks like now. And that'll eventually average out. I guess we just got to do it that way. And that's with the filter fully open. So we should be seeing as much of a flat line as I guess we're getting here. It would be nice if that would adjust live and give me like a live average, but... Pink noise, full spectrum noise is better to see sweeps. I don't have the choice. I've got whatever the hell noise Kinks puts out. Looks like it could be a Pink Floyd album cover. That's when you start messing with the color swatches on your picture and you get all kinds of weird stuff. I don't know what it's actually trying to display here. You know, I know this is frequency, but in terms of like why it's choosing what colors to display, no idea. I think that's depending on how much it runs over itself, maybe. Oh man, we've got a thunderstorm out there and they are cleaning the yards. Crazy. So in terms of adjusting gain, I do not know what I'm doing. If I bring this back so that it looks nice and clean, like that, let's see what the spectrum looks like. If it still resembles just a red hill. And I wish there was a way that I could have a button that would reset that persistence. Because on the outside of the scope, I've got all kinds of buttons for like clear. Clear doesn't clear. It doesn't clear this side. It'll clear this side if I put persistence on over here. But this is like, persisting this is useless. We've got an ad break coming up in 2 minutes. It's added for taste. Yeah, it's just it's like salt. Did that bring the lower frequencies down a bit? I think it did. Well, if I've got this in tune like this, what does that look like for a frequency sweep? Luckily, our sweeping is still going on. This is why I need to listen to Julian and make some of those switch panels. I could have it on a switch panel and I could just switch this between 2 different outputs. That'd be kind of cool. So it's still, as the frequency gets higher, I lose gain very quickly. We're going to have lawnmowers come through here in just a minute. So my audio is going to be a little bit crazy. See, look, the frequency sweep, there's extra, it's got way more gain from the frequency sweep. I think the analysis is a little cleaner. I just wish I had a button for that. Whoop. Yeah, look at how much cleaner that is. Dude. Well, why is it going so low on the higher frequency stuff? Shouldn't it be persisting? Because I don't have the filters closed at all. So, I mean, I think that's roughly what they... What? Don't stop pouring until my Perry's... Blah, 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 blah. You're talking crazy. Okay, so that's not the response I'm seeing. I'm seeing that. Low pass frequency at maximum, high pass frequency at maximum. We don't see a spike at the end, though. We're seeing sort of more or less of a slope. But if I do the low pass frequency at the minimum and the high pass frequency at the minimum, let's see if we can observe something that looks like that. So this all the way to there, this all the way to there, and then we reset our persistence. Not quite my tempo. You see, I've been getting the same response from this thing throughout. This should instead look like a little hill. That's why I think something is actually wrong with it at this point. Oh, there goes resonance. Ugh. Yeah, I don't. Something's wrong with it. Something's wrong with it. Something's not working right. I don't think it's an adjustment. I don't think this is an adjustment issue because I'm seeing the same frequency response no matter what I try. Ad break in progress. All those colored dyes. So I think something is wrong with, I think my filter kind of works, but I think something is wrong with it. Audio still gets fully through it. And maybe it is a factor of actually adjusting it, but I should be in like a known decent range. I'm going to turn both filters on. It should be filtering out this stuff, not allowing, with so little gain too. So I think that's indicative of a problem. I think we actually do have a problem with this. So let's, it's just weird because if I take noise and I put noise in there, yeah, noise seems to, and the frequency sweep is not relevant now. There's noise. Noise, noise, noise. You can see the resonance in there with the amplitude going up and down. Turn the resonance down. The signal gets way less noisy. Turn that down, turn that down. Now we've got the high pass and the low pass coming through. So you can see those more, the higher frequencies where it moves very quickly. And then I can bring the resonance back up until it's unstable, which is right there, and then bring that down a little bit. Supposedly that is how it should be working. And so our frequency sweep, and it doesn't quite look like what they're showing us here. And I certainly don't get the two spikes that they're getting, no matter how I adjust it. Oh, there goes that. And then at the same time, Code Rush, rating with a party of 3. How's it going, Code Rush? We're in the middle of an ad break, so yeah, the rate indicator is going off. Then it's going to go off for an ad. So like, what could be wrong here? I don't know. If some of the parts of the filter aren't installed right, maybe it's just allowing stuff to pass. But it seems like low frequencies are getting through way too much. High frequencies aren't getting through at all. Maybe I have to slide that window back and forth of adjustment. That could be one thing. Yeah, I am not sure. Supposedly we're back from an ad break. That thing should go off again. Maybe I said it wrong. Anyway, hey, welcome back. So we're adjusting a filter. we're trying to see if a filter works. Yeah, or if something along the, there's a lot of, like a long line of things that have to go right for this thing to output audio at all. And so what I'm doing is I'm injecting noise, and the only noise source that I have is from my Kinks module. The Mutable Instruments Kinks has a noise output that it's able to produce. It did go off and then turn back on. Oh, okay, yeah. Well, no, it's supposed to go 8 seconds after the ad overlay disappears, so that I'm not mid-sentence when I say welcome back. Anyway, yeah, so we're injecting noise into this filter, and we're listening to the other end of it. The Steve's MS-22 filter is unfortunately a layered hamburger of circuit boards, and that makes it hard to get to when you're when you're adjusting it. Yeah, stop talking about your kink. Yeah, I know. The Kinks module, the Mutable Instruments modules will have you talking about clouds and kinks and all that stuff. I didn't name these things. Can't blame me for that. So what we're doing is we are using a fast Fourier transform on an oscilloscope, a very nice oscilloscope. We got a fast Fourier transform that can show us the frequencies in the audible range. So I had to do a bunch of adjustment in order to get that to show, but the fast Fourier transform is not all that useful without persistence. And so I have to turn on what's called color grading in order to kind of see that whole thing. Now, we still see what this waveform, you know, what the noise filtering looks like anyway. But what's not happening is as I adjust these, we should be seeing something at all happen to that waveform. And I'm not seeing anything happen to that waveform. If I do the low pass filter, whoa, we go back into resonance. I got to adjust resonance down so that this thing doesn't blow it up. I don't know why you need to have some resonance on there, but apparently that's part of the process. What we should be seeing is like a bump sort of move through that spectrum. And I ain't seeing nothing. I see nothing happening. And actually when I turn both filters up to their maximum, yeah, see, it starts to get rid of the waveform. And let's see if I can get that to actually do something. This is where I got frustrated and wasn't able to observe anything happening when I moved stuff around. And I'm starting to think that something physically is wrong. Because, like, that, is it low pass, then high pass? I gotta see. I don't remember any of this stuff. Yeah, low pass, high pass. So low pass, high pass. Those of you who are in vertical video, I'm sitting over here twiddling my knobs and hoping to see something happen from it. But like there, amplitude went way down. And our amplitude is going up, 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 up. So that's the low pass. Sorry, that was high pass. This is low pass. That's not doing anything. So if I've got this all the way here, then low pass, high pass, and then what? Oh God, what's the order? Low pass, then high pass. Okay, low pass is the top. So that means that I should adjust. If I've got the top all the way filtering out our lows, then we shouldn't have all this amplitude. I'm not really seeing anything happen here. So turn that one up there. Now we're filtering both low and high, and this brings it back in. There's a little bit of useless range there. Actually, might be pretty good, actually. That is not showing me anything happen. High pass is down here. We're looking at low pass. And if I filter the highs out, we're still getting stuff getting through. There we go. Wait a minute. Yes. Okay. And then bring that low back in. Okay. That appears to be doing something for its whole spread. There to there. Just looking at the amplitude of the noise coming out is what I'm, and you guys can see a little bit, you can see that bump travel. Maybe not as pronounced. Oops. That thing back. I don't know if I should attach kinks or not. Kinks, I don't know about the noise coming out of kinks. I don't know how useful it is. Resonance goes crazy there. I don't know what that's all about. That seems really dangerous in a modular synthesizer for resonance to suddenly, it just cascades. You get a resonance cascade. Wait a minute. Gordon, to the chamber. Like, I guess this is what's supposed to happen. You can see it functioning. That should be fully open on the high frequencies. So maybe that needs a little bit of adjustment there. That's more like it. But then what happens if I let the lows in? We're close to clipping. So filter out the highs. Why isn't this? Oh, because the I didn't tighten these enough. My knobs! How's it going, Fear Willies? Hope you're having a wonderful day. I'm doing okay. Doing okay. We're having a good time. I'm making progress with this. It seems like the filter is okay. It's, you know what? I'm going to get the wrench out and tighten that one. Get to the wrench. Willow's barking her head off at people just trying to clean up the yard. There's a weed whacker out there. There you go. Keep that over here. Keep that over here. There's much adjusting to do. Twiddling our knobs. All right, so now I'm going to turn it to a center position. There. And get this thing back on with the mark on it. Julian was so weird about the marks on these. I think what I need to do is take these knobs and take a little drill bit and just drill out the little dot on them. And that way the dot will be visible. It'll be like bare aluminum. But I love these knobs. They're metal and they feel nice and they got a nice knurled edge to them. Julian was such a weirdo about them. Oh, now it smells like two-stroke fuel in here. All right, so I'm feeling a little better about that gain not dropping off on high frequencies. That's still a little bit... Well, that's full low. And then this is... Is it full high? What direction am I going in for this? Oops. Turn off the CV. Okay, that's filtering the highs there. This is filtering the lows here. And there they come back in. Those are the lows. These are the highs. And the highs now have as much gain as everybody else. They're sitting at around plus minus 5 volts. They maybe could use a little bit more, but I think it starts to clip as I go into the high frequencies is out here. What's this gain? Yeah, see, I can bring it up a little bit. That's probably decently accurate. And as soon as I start messing with it... That was the wrong one. As soon as I start messing with it, we see a change in the waveform. You know, that might actually be it. That might actually be okay now. Although technically I really should be seeing something in the spectrum analyzer. Let's see what it looks like under sweeps, I guess. Because that looks a lot better from my standpoint. I think we might have gotten this one. We might actually have this thing adjusted. I don't want this falling in like that. It's going to short out. So that's our frequency sweep. Little nubulon going across there. Why is it getting so quiet though? Like it's like huge over there and then it really like tapers off. Maybe sweeping the frequencies wasn't what it's called for. But I mean, that should be okay. It just, the amplitude drops off like immediately. I don't know why that's happening. Because our original signal looks like that. It's not dropping off at all. Whereas this one, like, immediately gives up the ghost. What's up, Virginky? And Peluser, how's everybody doing? AI solved the center div problem. We're officially in the singularity. What are you talking about? No way. Yeah. What are happen? So I like, why does it drop off so much? I mean, I guess maybe that's just the response to higher frequencies, but it really, like, our amplitude is gone. Maybe that's something to do with the hardware. Let's persist the scope here. See what that that little frequency lump. Okay, it just looks like a sweep again. Like, I can literally put the noise from kinks into this, and I can observe the differences in amplitude from the noise, right? I don't have it on anything official. It's just literally looking at it. Just literally looking at the amplitude gives me an idea of what's going on without even needing, you know, frequency measurement stuff. Let me get a longer cable for this, because kinks just keeps getting pulled. I keep pulling out my kinks. Actually, I'm going to attach kinks, and then I should probably, my powered multi, the one that's the bad circuit, this one that works, I should probably attach that here too. This is just where all of my derelict equipment goes. But oh, I don't have bolts right now. M2.5s to put on that. Actually, we could just use these. It'll look silly, but whatever. I ask of you, when has it not looked silly? Wait. These are M2.5? They should go on there. They're not. Was it a bad buy? No, these are just different hardware. Okay, never mind. These will screw into each other, yeah. Okay, never mind, never mind, never mind. I bought a pack of like 200 of these things just because I ran out. All right, so yeah, we're taking a look at that spectrum there, and that's looking okay. But the thing that bugs me is when I plug in noise from kinks into the input. That noise appears to be coming through fully. I can't compare it because I don't have it running through the scope, but we're comparing input to output. But if I lower the window for the high pass, you can see the high frequencies drop out. And those are the little movements that it's making. And if I drop the low, you can see it's only high frequencies now. And if I drop both, we get very little back, although that's probably more going through this than we should probably see. If we get rid of the resonance, it gets a little quieter. It doesn't quite get quiet though. And there's where a resonance blows up. These are just CV inputs. Oh no, that's the gain. If I turn down the gain, of course it goes completely dead without gain. Although no meaningful gain down here. That's a lot of gain, and it seems to be cutting my signals in the end. I only have so many adjustments here. Just going in two directions to see if I can see anything happening. The filter is, let's see, okay, so that's fully open. And now that's fully open. So we see all the high and low frequencies there. Probably dial back the gain a little bit here. Or no, this is the low pass filter. I'm seeing like nothing. It's just nothing is happening when I adjust. Yeah, there, that's pulling it in a little bit. I think. I don't know. Yeah, so this filter's kicking my ass. I don't know if you guys can see this or not, but I'm like SOL on adjusting it. It's not quite doing what I thought it would be doing, and our spectrum doesn't look like what they describe. So what is wrong? I think we need to take a look at the hardware a little bit now. I think I need to just take a look at the hardware and maybe trace back a path on the PCB to see if we can observe something wrong, anything wrong, a bad solder joint, something like that. I have so many more filters to get to. I've got this big pile of filters sitting back there. Oh, it's both raining and the guys on the mowers are out there. How waterproof is a lawnmower? I guess pretty decently waterproof, huh? Until the motor goes under. As long as you keep the motor above the water. This goes up here. I'm trying to make a little space so I can fit everything now. Because we got to take a look at the circuit board up close and personal. See what's wrong with it. If anything, I mean, it's possible that I've built everything exactly correct and there's nothing wrong with it, and it's just, you know, my own inability to adjust everything that's coming to fruition here. Before my plans come to fruition. Okay, a little bit of space. We can get the scope out of here for now. Scope is going to tirelessly perform a fast Fourier transform while we're working on other stuff over here. Feels like a waste, but I guess that's its job. That's what it does. I did all the filing for this hardware off camera. There's quite a bit of filing to do to get these posts to be to have the right amount of threads underneath them, and then I had to put washers on them because they just barely didn't fit. They were crushing things a little bit. But now everybody's together. So I just got to keep my hardware in one place so I don't misplace any of these precious screws. It's weird that I was able to observe the filter's behavior with the noise and not with the frequency sweep. And the frequency sweep didn't really show us the same stuff that the filter did. We did the frequency sweep, it's like suddenly the amplitude would drop off extremely. I don't understand why that would be on specific things. Now the next, this layer you have to put in like down and over because the LEDs go to the lower board. Down and over, there we go. Okay, there's a lot of little parts go into this thing. Let's take a look at our audio path and see if there's anything weird along the way, huh? So we start off with Steve's MS-22 and our input. So in comes our signal, and it goes up and over, and then it almost immediately goes to the second pin. Our output is coming from that corner pin there, and it goes through a little 10 kilo ohm resistor and out to the output plug. So our input is coming up and over to that second plug right there. So that plugs into this. And it plugs in this way. And it goes to that pin right there. I need a pointing device. My giant fingies are not good at accurately pointing things out. So we're going to this pin here. This pin here, which doesn't go anywhere else on this layer, but it does somehow come out of the header. And I believe it's this one right here. This goes over and then diagonally down to that pin. This one comes up diagonally from that pin. And so that's our output, that's our input. And our input just jumps right over. Just jumps right over. Nice logical design on that tree. This is why I would very much like a schematic. That's a little weird. No, that is soldered. It looked like a cold joint on that, but that is actually soldered. So our output coming from here, or our input rather, goes in here, jump over to, looks like it goes to this 510. What's the value on that one? I think it's 510. 510 ohms. And then we go under the chip where we encounter one of these amplifiers here. That's our input, so that's unity gain there because that's, those two are connected. And our amplifiers are output plus minus, I think, or minus plus. Hold on, let's take a look at the data sheet. These are TLO74s, which are kind of a common operational amplifier. They have a common output for this sort of thing. Man, I got a huge headache today. This is the second day in a row that I've had a headache. I wonder if I have a brain tumor. Yeah, output minus plus. Output minus plus. So far, I'm not seeing anything too crazy about this specific circuit or the construction of it. All of the, I'm looking at sort of the ends of all of these components, and I'm making sure that it looks like the solder has indeed propagated to both things. It looks like it has on most of these. That's not supposed to be installed, so it's not. That is looking a little funny, but it does kind of flow into it properly. I mean, like, all of these are like barely looking a little weird. I don't think any of them would have a deleterious effect on the, what do you call it? Flow of frequencies through this thing. Oh, it's really raining out. That rain's coming down hard, and the dog is just barking at it. I don't know to what end. What do you hope to accomplish there, Bubby? Why are you barking? All right, that one, maybe. I don't think it was a problem, but it looks like it could use a little bit of solder. What's going on here? There you go. I don't think that would have been the problem, but we'll just put that there just in case. Okay, so we've got something unity gain. We have something flowing in here. I don't want to bring out my multimeter to test which pin it goes to. Can we see, like, okay, output there, and then output here, output here. Huh, yeah, it's going all over the place after that, huh? Oh, am I gonna have to get a schematic for this thing? Well, okay, so those are all control voltage related, so there's nothing really wrong in this section. It's the high pass and the low pass filter that I really want to take a look at, just to see if there are any transistor legs or IC legs that look like they could use a little bit of love. I have this this very strong feeling that this is an adjustment issue. If we trace the output, by the way, it goes all the way down to this board. And it's this pin here, and then it goes all the way down to here, where it either goes up this way or over and around. 15,000 years of domestication has made dogs into living motion sensors. Yeah, pretty much. That's how she operates. I don't know which one, because this right here, this pin right here is our output. And so I don't know if it's coming up and over, in which case it does go to the output of this unity gain op amp, which would be after the LM113700. I guess that is what's going on here. But a lot of this stuff is baffling to me. I don't know what the circuit structures are. Maybe I do need to send 3 Toms an email and say, hey, you guys got a schematic. Because, like, I don't see any issue. Maybe. But I think when I was observing it super close, I did see solder on that. But let's just hit that with a little dollop. It just seems so strange to me that it's the frequency drops off on a frequency sweep like that. But when I put noise in there, I guess you're not seeing the higher frequency response. You're just it's buried in with the low frequency response. That didn't work at all. Didn't work at all. I don't have this on anything, so ooh, big thunder. Yeah, we've got little pop-up storms rolling through, and something just blew up outside. And remember, kids, if I lose power, I probably will not realize it, but the stream will drop out and it won't come back. I'll keep things powered down during the storm. Yep, and there we go. The little trace on those 2 pins made it so that they connected now. Those are connected anyway, but we should clean this up a little bit. It's a short jump from not enough solder to bridge with the size of these electronics. Try to use surface tension and draw out just a little bit of the solder, a little bit of the excess. No, that didn't work at all. Remember to stay centered. That way, the phone users, all one person. Why would you watch me in vertical format? Shame on you. Tilt your phones. Why are we not picking it up? Iron's on. I guess I got a little bit of it there. I really should be working in this direction. All right, there are no excess of solder, but everybody is definitely attached. Aren't you vertical? My eyes are situated next to each other. I'm not sure about your eyes. So I see horizontally. You know, we see things in that aspect ratio. That's why that was invented. But apparently TikTok has single-handedly... Ooh, look at that one. That one right there. That looks like it... Oh no, that's perfectly fine. It just wasn't as outward in its display of the solder. Well, maybe it's not perfectly fine. See, I'm hoping for a smoking gun, but we're not going to get one. That seems weird. What's going on with you? Dealer choice. Leave it up to the dealer, huh? 5 on the 9s. Got good farts going here today. Where I come in and I just ruin the soldering that I've already done. Yeah, I'm just looking for any solder joints that look like they might not be doing their job. Something that might be causing this filter to somehow drop off in its amplitude as we get to the higher frequencies, which may just be a natural thing that's supposed to happen, but it seemed a little, I don't know, it seemed like it wasn't really supposed to. I may need to get a schematic for this thing to finally troubleshoot it and make sure that it works properly. Or hand it over to Julian and see what he says. Back from bacon acquisition mission. Oh, out to the shops. I need to cook bacon. Last time I did bacon, I cooked it all in the oven and everything smelled like bacon and I had all this bacon and then I put bacon in a bunch of stuff. I had some BLTs and stuff and then I didn't have bacon and I was sad. Once more, I was sad. We're kind of going over the soldering because I didn't like the difference in amplitude for the frequency sweep versus the noise from kinks. The noise from kinks seemed to keep its amplitude in spite of the adjusting of the high pass and low pass filter, whereas the amplitude from the frequency sweep would drop off greatly at higher frequencies. It was actually really weird. Storytelling by Bother, where I forget what I'm talking about. Aren't eyes horizontal just so we can perceive depth on a screen? There is no depth. Man, like, come on. The aspect ratios of the screen we use, yes, the depth perception is the purpose of having eyes that are next to each other, but as a result, our visual acuity is essentially laid out in the original film format. That's what it was formatted for, was the you know, where we are most visually active. The vertical video is not it. You can't argue for that. It never lasts long enough to put in anything apart from directly in my stomach, straight from the pan. Exactly. On bacon consumption. I'm not seeing anything wrong with the soldering though. That's the problem. And if I get further into it, if I really want to actually observe filter paths, then I have to get a schematic of this thing, because nothing is wrong with the soldering. It's a big, complicated filter for just being a low and a high pass, but I really don't see anything that's troubling me. That's all in there. Oh, it's really raining out now. Hear it coming down. Whew. You can argue for it when you're laying down in bed, even still. Because your eyes actually do this a little bit. They don't do it at a certain point, but like your eyes will actually tilt a little. Big rain, big rain, big rain. Big raining. Sometimes when you tilt the board like this, you'll see that your components have like tombstoned, which is where they actually stand up on one end. So observing it like this is very much a part of inspecting something that you've hand built. This is all hand soldered by me. Hand soldered by a bother. I mean, I don't like the look of that one, but it is in. No, sir. I don't like it. Oh, what's that one doing? One's looking a little weird. This guy. You need you to sit down. Sometimes you can heat through the resistor and get both pads, and then you can kind of like nudge the component like that, and it'll kind of lay itself back into place. But that was, I mean, that was still connected in spite of it sitting up. None of these look particularly damning in terms of this one could use a little love. What is it doing now? It's being weird. Oh boy, come on. You little... Lots of rain. Oh, my headache's starting to go away too. This little atmospheric pressure change. Let me nudge. It's like it won't let me nudge it from this side. Has to be the other side. I mean, I guess that's soldered in. I don't like it, but that is definitely attached. I got solder flowing all the way up to the top of it. It's just not even. I guess I could drop a bunch of flux on it, and then that would even it out. It does look a little weird, but I do see solder flowing on the top of it, so I think that means that it's fine. Like a bad component or something would really make my day right now. Yeah, I don't know. It must be an adjustment thing. Could be a requisite number of curse words that I have to hurl at it in order to get it to function. Because I seem to observe frequencies going into it and it adjusting those frequencies, but the response is not what I would expect. But then again, I'm not putting audio into it, and maybe if I put audio into it, but the gain is like not there. There's like no gain. Well, no, but for the higher frequencies there is. Or the lower frequencies rather. Lower frequencies, there's plenty of gain. It keeps all of its gain, everything stays within spec. For the higher frequencies, it's dropping off pretty quickly, which it probably shouldn't do. Well, let's plug it back in and see if anything we did there did. I don't think anything we did was going to make any kind of a difference. It was mostly cosmetic laying down of resistors, but having looked at all of the joints, they look fine. This thing is a big build. I mean, this is like a lot of work. This is a lot of work for me to just say, it doesn't work. You know, at the 11th hour, just go, nah, it just doesn't work. That's not, I can't do that. I have to actually get this thing to function. And be a viable piece of my whole synthesizer. Pretty hefty stack of boards, though. I do like that about this, is that there's a lot going on here. It's not all crammed into one little thing. You can kind of see your functional groups of the components. Sure would be nice if they put out a schematic, though. Could use one of those. Okay, so we're back together. Get the scope back in here. We'll put noise back into it, and I can just show what I've observed and why I think something is weird. And maybe some magical member of chat will have something to share to help me make sense of this. And then we'll move on. We'll do like the serious filter tuning, and you know, we can look at some of the other ones. Yeah, it's a lasagna form factor. There's layers of meat and cheese and all kinds of stuff going on here. It's crazy that you would stack this many boards like that, though. Usually what they'll do is they'll just do a big right-angle board that has everything on it. And so if you had the surface area of all three of these next to each other, just sticking out the back here, you can have a lot of circuitry on that. You could do a lot with that. They may have been hurting themselves by doing the burger stack. All right, so this thing's on, this thing's on. Noise into the input. And then noise to the scope. And then we take a look at our Fourier transform, make sure we're on channel 2. We can reset that. And then we've got all of our frequencies coming in. All of our frequencies are coming in over here. And we can see that our filter just kind of has a particular shape to it. And when I turn up some of the filtration here, if I had both of these sitting at about the same thing, what we should see is 2 poles on this thing, but we're not. I don't know if it's the type of transfer that I'm using. Like that pole over there is not moving. But I do have it so that when you do adjust these, you see something is happening. Like if I take the low pass up, there's no more lows. And I take the high pass down, now there's nothing. Take the high pass up, we get some of those highs back. Although there's not as much amplitude as I would like there. Turn the gain way up. Yeah, the gain, whoa, that's resonance. Gain is not quite there for the high pass, is it? Bring that back in. There's our high pass gain. There we go. And so when I start to adjust it, yeah, there, see, it's okay. Well, it doesn't defeat that quite as much, which I guess is this other control here. So I want that gone. That's the start of our window. And then I go to the other side of the high pass. And we need more gain. Whoa, that was a sudden jump. Right there. So, okay, high pass. No, we've got the amplitude, but we don't have it. It should be, when I turn the frequency down on the high pass filter, I guess it's filtering more or something. That doesn't, it feels like it's not doing anything. See, this is where I get into trouble, because all right, as soon as I back off on this, yeah, we're starting to get some of that amplitude back. So that's the other side of the window. So I'll go back in with this until I tamp it out, and I don't see nothing no more. I've got the gain all the way up, so when I go back on this, I need a little bit more gain. To about there. I do see some peaks actually in the spectrum there. I wonder if those are outliers. There's a couple little lumps over here. So like fully closed filter and there's still stuff getting through it. Okay, so that's slowly doing that. So do. Kill it, kill it, kill it. Kill the frequencies. Kill, kill, kill. I can't anymore. See, at a certain point, you see it start to get louder. And then here we get quieter, quieter, quieter. And then stops getting quieter. So if I undo the filter there, I can see it adjusting from the very beginning. Okay. So I think that is close to properly adjusted, although maybe if I'd sacrifice the gain in order to lower that a little bit. There. Even though there's still a pretty good amount of amplitude on that. Yeah, but now I don't get my gain back. Okay, so that's... Ugh. What the butt? What the butt? Okay, so tamp that, let the lows back in. So there's the lows. They certainly are in there. Big lows, and that adjusts from the whole range, just about. But it might be that the lows are a little too... Where do we get it back here? Okay, so that's low, low. Go back in with this. That's pretty reasonable. So the problem is, this is the closed filter, and we're still getting all this stuff coming out the other end. Turn the resonance up, blow it up, blow it up, blow up everyone. Turn the resonance back down. This is resonance becomes unstable and it starts to oscillate because you've got things feeding back into itself. So this is a fairly sensitive control from blowing your speaker up, it blows up your whole house, to giving you a pleasant amount of resonance coming back in. And then I can turn it off with that. I think this is how it's supposed to function, though. Although I don't know about this. What's that? He chose the errata information on the bottom of the bill of materials. What's the errata info? I think I caught it. Let's see. MS-22. This isn't the bill of materials, but feedback from Robert DeVeers. Fix the line that said the high pass is going into the low pass while it's actually the other way around. Added Appendix A, calibration. That's what we're working on. We're working on the actual like manual. The bill of materials, I got that somewhere around here. Hold on. Where is that? Well, we got the build guide. Is that what you mean? Oh, bill of materials for the old PCB set. What do we have? Please stop, Firefox. These override the values above. Oh. I followed their guide, and it was, I think... Oh, I forget which guide it was. We'll check up on those values, though. Maybe that's it. They've got a really nice guide for all this stuff that brings you through the build in their fashion. And it's, yeah, okay, so I do have that. So yeah, it starts off with the corrections. And I did perform these. I put these in. Which is annoying that I did that, because otherwise we would have the smoking gun, the actual thing that destroy, you know, keeps this thing from functioning would be, oops, I didn't do this. And then we'd have a clear plan in front of us. But I did do this. I did this. I think mostly what I'm doing is I'm just trying to tune the windows of the filter so that we've got the right stuff. These were, okay, so that one versus the bill of materials one is 51K, 100 and 200, 100, 200, 470 or 510 from R34, if that's referring to the same board. So those are the only corrections that I did. So perhaps these three right here. Oh, I gotta find these. Oh Jesus. Okay, hold on. This was a lot. This build was a lot. The build was a lot, and then they instruct you by color coding everything on this instead of telling you R24 is this value. It's you got to follow the color codes. Don't need to mount these actually. Oh, okay. I marked all the ones that shouldn't be mounted, but let's oh boy, back to the boards. Let's see if we can find these other ones. So these would be 34, 203, and 204. Turn the system off. Let's bring all the boards out again. See what we can do with this. Maybe that'll... I don't think that's going to like flip the switch from broken to fixed, but might as well give it a go. And then this, okay. Father, your Google storage is running low. I know, I keep cleaning it out. I don't know where all that storage is going. I don't know what's filling it up. Phone backups, maybe? Boy, it is a proper rainy day out there. Got a couple storms rolling through, but right now it's just straight up raining. Rain, rain, rain. Is it any getting inside? No, we're good. It's not blowing. You gotta watch out for that. The wind blowing rain onto all of my 3D printer filament because I store it right beneath the window in the open without any desiccant, and it works fine. It's PETG. Everybody says, it'll take on moisture, it'll take on moisture. No, it's fine. It's been fine. Print's fine. Ad break. So we're going into another ad break, and I apologize again, but I have systems that make me aware like that of where the ad breaks are happening, so we don't talk about too much stuff. I don't leave certain chat members behind by running these ads, but we get about an hour now that we've run 2 ad breaks. All right, so let's take a look here. We are looking, oh God, we're never going to be able to freaking find this thing. Looking for R34. Not rule 34, we're looking for R34, as in the resistor. You perverts. C25, R53. Some of the resistors are labeled in the middle. Watch players. I had some ABS Plus, which absorbed water. I thought there was a mechanical issue with the printer. It came out so bad. I do have a filament dryer over there just in case, but for the most part, I have not needed to use it at all. Even though the PETG is literally stored under a window, a basement window, so the ground level is right outside of that window, and it splashes every now and then. That window gets wet sometimes. These are in the 50s, so I think we're on a different board. That's D1 and D2. And C... that R something or other, R13. We are looking for R34. If you guys have any good links for R34, don't share them. There's 43, we're getting close. It's 34. These are all to do with the LEDs though. I don't know why we would be, a bear shits in the wood. She sells, okay, 22, 24, 25, 33, 34. That one is a 514. And this one says 470K or 510K. So that's 510K that we put in there. That's to do with the lighting though. That has nothing to do with, well, the control signals too. So yeah, we got that. Apparently that one's fine. Okay, next one is R203 being open. 203 is down here in the cluster of functionality for one of the filters. And then we get an indicator that we're back from ads right now. There we go. Back from ads. Welcome back, advertisement watchers. We're looking through the R's and the C's and the P's and the T's and the whatever in order to make sure that we've got the right value components in here. There was a little bit of errata from the guide that I followed, but then there's extra stuff attached to the bill of materials that I missed. Although it seems like they're in spec. We're looking for R203. So we're just looking through the C's and the R's. These look a little blurry. That's because it's a small font size on the silk screen. This kind of feels like a Seed Studio board, like the ones that I normally order. And their silk screen gets very blurry when you get down in size. What I opt to do is just have all the silk screen markings off the board and then use my computer files in order to find everybody. That's 121. We're looking for 203, so we're not yet in 200. So it's the other board. 59, 79. These are in the hundreds. 105, 108. We're looking for 200. 3. Well, those are going to be impossible. 1827. All right, 1927. So is R203 like one of these that I'm never ever going to get to? R10. 8, 9. Those are all for the LEDs. 210. Where is 210? This would be at the ass end of this board. 138, 137, 124, 45. We're looking for R203 and 204. And one of them might not be populated. The unpopulated ones over here, 160s, 168, 170, 150s, 130s, 110, 171, 123, 124. Does our board go up to that? That's the other good question. 117. It could be for the other revision of the board that they have. I mean, I reasonably expect that I would have done the right stuff. These don't get anywhere near 200, right? Oh, here we go. 202. 203 unpopulated, that's correct. And 204, 0 ohms populated. Yeah, so I'm, okay, so we got all the errata in there. We've got all that. So all of these have all been confirmed. These are all actually put in there. So yeah, it was a good check. It was a good check to run. I mean, I don't, you know, obviously running it potentially could save us from issue if there were in fact issues, but I do have all of the correct components in from following the guide. So I don't know, it feels maybe just like this is me problem. I'm not seeing these kinds of filter responses. That's what I'm talking about. That's why I'm kind of like, you you know, flailing about right now. If I put audio through this thing, it may just work. It just seems like as we get to the higher frequencies, things are dropping off really sharply. And maybe that's just what they do, but it just felt like every single one of my charts. Oh, what did I just hit? Oh, that was my thinking music. Every single one of my charts ends up looking like this, just like the side of a hill. I'm not getting anything that looks as dynamic as what's in the images above. Nothing looks like that for me. But when I observe white noise from my Kinks module going into this thing, the response appears what you would expect. I mean, when you turn up, if you're looking at the noise and you're looking at all the big moving values, it looks like when you turn up the low pass filter, the lows are going away and the highs are remaining. And then when you turn up the high pass filter, it looks like the highs are going away and the lows are remaining. Like, all that seems fine. I'm just worried about the filter response that I'm getting, not quite agreeing. But it seems as though I have crossed my T's and dotted all of my I's. I've got all the right components in here. The soldering looks fine. I've gone over a little bit of the soldering and had no change in behavior whatsoever from the filter module. It may just be time for me to move on and I can plug this thing into something later. I've adjusted the gains to where I'm kind of okay with them, but it still looks like when I turn the filters up, it's not tamping down the signal as much as I thought that it would be, much as I thought that it should. But that's visually, you know, observing the amplitude of the noise that I'm getting out of the other end of the module. And again, Kinks noise is not necessarily the right kind of noise. I may need to make like a noise program for my module testing module. I may need to make like another mode, and I don't know what kind of noise I can pump out of the I2S modules that I'm using in my tester, my module tester. Maybe I need to make a module tester. Maybe the tester for the module tester needs a tester to test the module tester. Module tester. Module. Okay, the word is meaningless now. It's semantic satiated semantically. All right, filters back together. Filter comes apart, filter goes back together. Filter comes apart, filter goes back together. I may move on to start working with some of these other modules and see what they do. We don't know what's wrong with Clouds. Clouds isn't transmitting properly, and we looked at Clouds a little bit, and we fell into one of those mutable instruments holes where you just don't know what the hell's going on. Like, why isn't this thing working properly? It seemed like our microcontroller wasn't communicating with the motor or the DAC, ADC DAC, the audio chip. And whether or not that's down to reprogramming this, I don't know. You know, I don't think it's down to solder. This seems to have the responses that I would expect when looking at noise, but when doing a frequency sweep, the amplitude drops off sharply, which is kind of weird. I can just hook that up and show, because it's easy to do. So let's say I'm hitting it with a sweep. So the sweep looks like this. Turn this on, doink. So the sweep's going in to the module, and then we observe on this plug the output from the filter. And if I turn this off so that we can see what's going on, well, first of all, we can see that our sweep is not lowering in amplitude as it gets to the higher frequencies. Absolutely not. This is a strong signal. So as we sweep through these frequencies, that's what's coming out, which is pathetic. Let's open up the filter. I think that's open. Oh, that, yeah, see, look at that. It just, you know. And if we observe the Fourier transform, yoink. What if I do VRMS instead of DVV? Maybe that'll show some slightly more filtery behavior. It already kind of seems to, although the frequencies aren't around long enough for it to... There's it with resonance. It's harder to observe, actually, with VRMS, but VRMS appears to be showing the slope slant sort of a little bit in reverse, though. Not as useful. You guys can't see it as easily. Jeez, that reset, there was chaos. Chaos, chaos. Oh, wait a minute. Yeah, actually, wait, that is what we're supposed to see. Hold on, let's turn this back over to DB. Reset it. Go back to DB. Okay. Seeing a little something here. See, there's actually like a slope now. And as it moves to the frequencies, you can see it emphasizing certain things. So it's actually, there's a little bit of a bump on that. Still doesn't look like any of the things they're saying I should see. It still doesn't look right. Ugh. Yeah, see how it kind of goes, ugh. But that's with both of these set all the way up as high as they go, which means we're filtering one. Yeah, but if I undo that, now it's a fully closed filter, so we really shouldn't even be seeing that. Geez, why was that so spiky? Yeah, I don't know, man. I don't know what's going on with this thing. I don't think this is an adjustment problem, but I don't think it's also a... I don't think it's a bother did anything wrong problem or a... Maybe I just need to listen to it. But the gain, like, the gain is all the way up. Like, we're at full gain here, which really should not be where this thing sits. So maybe maybe it is an adjustment issue. If I take the gain to the middle and adjust it, maybe that's what I was supposed to do. That may be the problem, actually. The problem may be that I set the gain too high. So let's open up the filter. Is that open or closed? What did I just do? I closed it. Open the filter. Where low pass is all the way low, high pass is all the way high, and then I adjust the gain from the center position instead of from all the way over here. And actually, if I give it regular noise, it gives me a bit of a better insight into what's going on, so that I can adjust these pots. Noise, noise, noise. Is that's closed? I think I closed the filter. I opened the filter. Oh, hello, hello, hello. What direction is open? Low pass, maximum, high pass, minimum. Low pass, maximum, high pass, minimum. Why is that still showing green? No. Oh. Wait, why is that changing that one? What the deuce? Wait a minute. Yeah, that one's doing that now. Why would that? Look at that. It's going from red to green. But this is adjusting this one, these three, and it's these three. So why does this change this one? What the butt? What's going on here? Somebody shorted out? That might be an indicator of a problem. Or it might be nothing. It might just be that the float level of this thing, 1 kilohertz test audio wave. I did that before, but putting noise into it is a way for us to like quickly observe the adjustments that I'm making, even though our noise isn't as comprehensive. as like an actual noise source. But if I put this into here and I turn its effect way up, and then I put it on the triangle sweep, yeah, that's sweeping. Oh, you guys can't see. Sorry. I need to readjust the way I do things. I need to work more in this area. So hold on, let me just adjust my camera and you guys can ride along with me. My Twitch is twitching out. There's, I don't know, big storms. I don't know, this won't affect you. What the hell happened there? Wait. Oh, because we're adjusting resonance, that's right. Yeah, these switches determine what the control voltage does. So if I turn that one on, that's going to go up and down with my triangle wave. Turn this one. Something ain't right. Yeah. Something ain't right. I'm gonna get myself connected. Writings on the wall. So that's not going negative. Oh, you know what? Wait, but does this one... Yeah, that one controls frequency. Then what's this do? Apparently it just messes this one up. Huh, weird. Oh, hold on a sec. I'm stupid. Hold on a sec. Switch has a different function. Ugh, I can't get my microscope in frame here. Yeah. 100%, 0%, 50%. And then this one does plus and minus. Controls voltage into this. That's what the rest of them do. So this top one is actually controllable with this input, which is on this plug here, FCV. So we go over to FCV. And now 100% control, and my triangle wave comes back and forth. Yoink. And yoink. 0% control, 50% control. Well, that's going fully back and forth. I don't know what's going on there. But then, why does this one get affected by it? That's kind of why I feel like it's like something's broken. But I guess that's maybe what's supposed to happen. I don't know. Weird. Weird. Okay, let's go back to opening the filter up and seeing if we can adjust things properly and get the control voltage out of here. So what I want to do is open the filter. And I think that's because low pass, high pass. So low goes low and high goes high. Is that open or is it the other way around? Let me double check with my documentation here. Double check with the documentation. Low pass cuts as you go to the left. So low pass to the right, high pass to the left. So I had it opposite way. This is open. And our gain is at 50%. And our resonance is not quite blowing up. There it goes. Kind of right before oscillation gives you nice resonance on there. Yeah, there is the best we get. I keep thinking you're Velkin, not Velkiden. Like, oh, Velkin's here. How's it going, dude? It's one of the moderators of Rabos. The best we get is the flow diagram here. We get a little, where is it? It's in the other document. Hold on, let me go get it. Let me get it. We get a, yeah, filter topography. So this is what it is. Oops, sorry. Off screen there. So we get gain on 2 stages, resonance on 2 stages, and then the low pass into a high pass. And then adjustment in interspersed into that. But that's what we get, right? Like so I should be seeing big wave. The Djibouti show watcher and also streamer, big wave. I always read as big weave. I'm like, dang, that's a lot of hair. Look at that weave. Okay, resonance down a little bit. This one is fully to the left, this one's fully to the right, meaning we're letting everybody in. And we get nothing. Good day to you, sir. So I'll go down here to my adjustments, and I've got low pass and high pass gain. So high pass is the one further down, low pass is the one in the middle. And no, here comes something. And that stopped moving, so let's try this one a little bit. I observe nothing. Please do something. This is where everything got out of whack and where we started our adjustments. Getting a little something back. This is way too much turning though. I've almost completely nullified. Oh, dropped off right there. I just don't feel, I feel like it's not doing anything. Yeah, see, that cuts it. And this will cut it for the... Well, that seems to do nothing now. And it could be that the window's shifted too far over too. Yeah, there we go. A little bit on the window, a little bit on the gain. But not really seeing much. Also, I'm not seeing a demonstrable change in gain when I do this. We saw the frequency come back when I adjusted the window, but oh, what the hell? This is what I'm talking about. Everything was going great until I started questioning some things, and then all of a sudden I feel like I'm not actually doing anything to this. Do I have these in the wrong position? No, because that cuts the highs out. And I feel like I should have been doing this with the gain set in the middle, and I didn't do that. I set the gain all the way up. See, that is boosting it at that point. The easiest way to bring it back, though. See, that's just cutting everybody. There's a lot. See, and that's just not doing anything. This is nothing. That cuts everything. If I let a little bit of it back in, it still doesn't do anything. What the hell? Oh, I had that one switched. Wait, does that mean... No. No, it's still, this is very frustrating. I may need to get a schematic from these guys just so I can observe some of the stuff going on. Maybe we should put ourselves back into the original configuration by measuring the resistances again. I need like a clip that'll clip on that does that. Because like, we had it so that it meaningfully adjusted everything, but then I started really twiddling around with the gain. So I need to do it from... Yeah, known good position. All right, let's get back into a known good position. Man, we cannot clock a win with this thing today, huh? Oh, that's my screwdriver! No! No! My screwdriver! Get my screwdriver that I just dropped. Those shelves have got to go back together soon. They're being weighed down by drill bits at the moment to try to keep the rubber that I put in the bottom, the sticky rubber that I put in the bottom, from curling, because it came in a roll and I did not uncurl the roll before I started cutting out little sheets of it to put at the bottom of that drawer thing. It's a drill bit storage. It's going to go in the corner by the milling machine, and that way I'll actually be able to find drill bits that work in some kind of a timely fashion. This is what happens. The cable drops directly down and it gets under the legs of the stool. All right. So now we got to go back to our known good values. Back to the known good values, and hopefully I can get it at least somewhat. Hey, what happened? Why do I have zero viewers? The room is in followers only mode. The room is no longer in slow mode. What the? Something happening to Twitch that I'm unaware of? Any of you YouTubers still there? Is it me? Hold on, let's check. Check what's going on here. Yeah, we got good connection on YouTube for my 2 viewers, but I had like 60 people here. Yeah, Twitch had some kind of a big hiccup. Yeah, it's not clocking any viewers. Something happened with Twitch. What's going on? Anybody still there? Twitch is fine in Connecticut? Okay. Yeah, because we just had and 0 viewers, and then we had all these connection issues right here. So something hiccuped. I don't know. Yeah, this is nothing new, but it's just nice to. Twitch has been decently stable recently, but I guess we've got some hiccups going on. Sent a fart. Yes, I received your fart. Please never cook again. Let's turn this off of persist mode because it's annoying looking. Hello, you come up. There you go. Doot. That looks a little better. Okay. Yeah, so we got to go back to the values that we know are good. So I need to go and adjust these again because we've been all over the place with the adjustments. Can't even chat over there? What, in Twitch? We've got Twitch chats rolling in, so I guess they fixed whatever was wrong. I keep finding these. I don't know, I think 2 of them escaped. These are ceramic for pies, for weighing down your pie crust. I tried to use those to fix the curling of the rubber on those drawers, but didn't work. All right, so back to ohms. Get all my ohmies together. Store that module in the small open-ended cylinder near your knees. I'm sorry? All right. Arm focus. Bring us back into here so I can do some ohming out of all these pads and get these to within specification. So I was doing that by having weird grip on one of these and coming into the back of the potentiometer. And then where'd my screwdriver go? There it is. Someone pushed to production. Oh no. You didn't hit okay on that, did you? It wasn't ready. It's gonna explode. So I'm putting this against my belly to hold it and observing. 4.7K. We need to be at, hold on, let me go back down to the little advice thing down here at the bottom. We need to be at 4. So we need to back this one off a little bit. Oh, trash can. Okay, sorry. I never know when you guys are being perverts or when you're... it's always a toss-up. When I don't have time to, like, process comments properly. Okay. We want 4K. Almost there. .9, I guess I'll take, but I'm going to just tweak it a little bit. Come on. What, really? .1. Yeah, we'll take 4.1. All right, next one. .8K. That was off by a little bit. Can I just circle around? I think these don't have like a stopper on them, so they just go, they go until they go to the minimum value. 1 ohm. Let's put that to the test. I'm going to keep going in the same direction. There's no resistance. Oh, no, it'll just stay at 1 ohm. Okay. Interesting. Well, now I know that. Got a data point on that one. My hand's starting to hurt. 4.5. I got really close first time. That was interesting. And 3, 2, 1, 0. Ah, 3.5. Too far. Doesn't really feel linear. Four. Got him. All right. Next one needs to be 13 to 14. So it's, well, technically 13.5 to 14.5. So I'm willing to accept 14K for both of these. So I need to get to the pin all the way in there. Oh, okay. We're good on that one. Funny. It didn't seem like it. .6. Back we go until we get to 14K. 17M. Error, error. This is what I mean with these high voltage probes. You can really get them into stuff because we got to go into this big burger stack of boards. So I'm able to get that. I'm able to maneuver that all the way in there and get a reading. Or not. Or I get a fluttery response. Oh, this one's really close now. Yeah, that's pretty much there. Why did it jump so far? I barely moved it. Weird. Maybe I was like off or something before. Yeah, now it's like really stable. I must have measured something badly. Poked something I wasn't supposed to poke. Okay, 13.9 I'm willing to accept. All right, so now we're back to the original values for for these adjustments. And I guess I can just compare it to the noise that I see. I didn't need the fast Fourier transfer if all I'm doing is, well, let's just do it at a better gain value. This time with the gain knob in the middle, that means it's able to boost a weak signal and tamp down a, yeah, because before the gain was like kind of unwieldy, so. This should get really crunchy. I'm scratching my ear. Give me one sec. Whew. Okay, there. I needed that. All right, scope back on. Boom. Boom. Scope. All right, and then bring this guy in, and we're not powered on, so that can get plugged in. Observe the stripe. So important. Of all of the things that I've fixed for my friends, all of the synthesizer modules that my friends have broken, chief among them, the thing that I keep seeing come back again and again and again and again, is they didn't look for the stripe when they plugged it in, and they plugged it in weird. They somehow managed to plug it in off center. You're not really supposed to be able to with these DuPont connectors. The insulation display, insulation displace IDF, whatever. With the flat cables, you look for that stripe, and that's going to tell you where pin 1 is, and pin 1 and 2 are -12. So on this one, they've labeled it with just a little stripe by the connection module and a lightning bolt, which is sort of non sequitur, but that just means that I need to plug this in this way, right? If you're doing modular synthesizers, please double check. Always double check that the arrow on pin 1 is going into the properly marked connector, because endless amounts of sorrow. All right, gain in the middle, low pass, high pass. Was that closed or open? Wait, high pass needs to be, this thing. Hold on, wait, we gotta check. I gotta check. I have to check. Okay. Low pass needs to be to the right, high pass to the left. I've said that before, but I just keep forgetting. So, low pass, open, high pass, open. Resonance, we're just going to park it to the side. Theirs had it like here, and I think that's where you start to see a little bit of resonance, but, well, maybe we just follow their instructions and, yeah, put that there. Switches are all neutral. And these two are, they can be anywhere. They're not useful. Turn them all the way down so that there's no outside influence of noise. We have my kink noise, my kinky noise right here. We're going to pipe that in, and then our output is the blue channel right here. We're going to pipe that out. And then we turn on the synthesizer tester, observe that it is using current. I think I have too many things plugged into the metered currents right now, but Bob's your uncle. All right, we've hit the ground running. The thing is, I'm not seeing much noise coming out of this thing. Yeah, that's filtering out the lows. Yep, okay, good. And then that filters out the highs. Why are there no lows? I mean, if I turn up the highs and we adjust the low, I guess maybe that is something that we need to do. So high pass filter on the bottom, low pass filter on the top. This goes low pass, high pass, I think. Yeah, low pass, high pass. So high pass is here, but it's the outside board. Low pass is here and it's above that. Okay, so let's start with opening up the high pass. Right? No, wait. Yeah, because the low pass opens up, we see everything. High pass should be open. So we should observe waveforms here. So let me adjust the gain on the high pass filter using the outside knob, which is gain. And then according to them, I'm just double checking all this stuff to see if anything is weird. Because if stuff is weird, that means that maybe it was assembled bad. Which is, you know, maybe it was assembled badly is pretty much like the maybe. I could just drop that out and just say it was assembled by me. So of course there's problems. Less, more. Negative, positive offset. So anti-clockwise, but if I turn that, yeah, less is this way. So more to the right, less to the left. So I want more gain. I can just do this with this up here. More gain, so I'm going to go on the outside of the outside for the high pass filter, and I'm going to go in the more direction. Every time I tweak it, something's happening. Turn the resonance up. Oh, that's getting all filtered out. Resonance back down. Definitely got noise going in there. I'm like 3 turns in and I'm already screwing it up. Why is that bottoming out? Maybe because the window's shifted? Okay, so that's with the full, and then that's nothing. So if I take it so that I start to see something there, shifting this, what direction? So towards the top is when I'm running out of stuff. Here, hold on. Nope, that one, there we go. Oh man, this is a lot weirder than I expected it to be today. Looks like I lost all my viewers. Everybody's Twitch hicked up, and then I lost all of my bots. I'll have to get more bots. I'll buy more bots from China for you guys. So this is disengaged low pass and fully engaged high pass. Or rather... okay. If I can get the direction of all this stuff correct. I'm surprised I'm able to watch your stream. Twitch is effed at the moment, and it's not good. Yeah, what's going on? Everybody's like screwing up. I just have Rabaz open on the other computer, and I can see it's fine. But some people are having big troubles, and I got, you know, my whole chat got blowed up. What? And now there's something in my inbox. Wait, what's in my inbox? Oh, that's not working. Oh, that's not working. There's something in my inbox, and I don't know what it is. I can't check it. Man, can the people who made the MS-22 please join my stream and help me out here? I have a feeling this is just like the issue that I'm having right now is just my inexperience with this thing. If I had a little bit more experience actually like seeing this thing function, it probably would make a lot more sense to me. But right now, fully opening the low pass means having it go here, and this goes here because it's the high pass the other way around. And then resonance, they brought it in until it became unstable. But I guess they were talking about other kinds of resonances. And gain in the middle, because while I could juice it up, see, that actually is giving it kind of a respectable amount of gain. And to be honest, difference between here and here. I mean, this should be an audio knob, right? Oh, the identifier is on the other side. I think I got that right, because the two are... They're viewing into the module tester. Where's my burger? Oh, jeez. Can't get... The microscope is aimed a little bit. Here, let's bring it up. There we go. Once more into the burger. B50, B50. This one would be an A, and then the rest of them would be Bs if we could actually see any of it. But it's all so compact and packed in that we cannot. But so, the difference between this gain and this gain is a huge signal, and having the gain up here is completely overwhelming the scope. Hold on, so what's our over-under on that? I'll go back to this view because it's a little less... It's claustrophobic, but it's a little less claustrophobic. The screen thing, the center screen thing is really weird. I'm trying to... I'm trying to keep the action in the center of the screen because it's a new thing. A new thing for them to auto-encode a phone-shaped stream. I really think they should just force people to turn their phones. There's no way it can go above 12 volts, yeah. So at full gain, it's all the way up at 12 volts, and then it drops off to like 5. That's really sensitive, though. I'm not able to see streams live. People I follow, streams live, people I follow, or other streams live at the moment. That's what's up with Twitch at the moment for me. Problem started around 3:30 p.m. Oh, jeez. So Twitch bungled something. They probably rolled out a new feature for vertical video. Who knows? Like, look, you can now have vertical video on your streams, and oops, everything broke. Production broke. See, that drops off really quickly. That tells me that it's at the wrong part of its range. And so having the gain there, I should have the gain at 50%, and then let's bring the voltage level back up so that we have an observable scene, because this is plus minus 5. It stays pretty respectably in that range. Holy hell. Actually, it's more than that. Oh, actually, this is 2 volts. Yeah, what's our voltage range here? It's like 3.5? No, it's at 3. It's at like 3 volts. Huh. Plus minus 3 volts for the noise. But then if I give it, I mean, this is more what we would expect from audio in our synths. Which this is plus minus 5, I think. Oh no, this is still 3? I thought I was plus minus 5. What's going on with that? Huh. Or is that... No, okay, that doesn't, it's not attenuating it. All right, you know what? It's like our amplitude is completely destroyed. Although it is nice with the frequency sweep, you can see the doot 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 doot. We got an ad break coming up. Also getting problems chatting too. A moment ago, oh Jesus Christ, what is going on? Can't like move the look at this. You have all filters set. There is the room is in followers only, slow mode, followers only, slow mode. Access denied. Sorry, only channels that can run ads have access to the ads manager. But an ad starts in 1 minute. What's going on? Why is Twitch breaking like this? Twitch, please, please. What's going on, Twitch? Please. Please fix yourself. I have other fish to fry today. I don't need Twitch to be one of them. Okay, our ad manager just came back. Everything but the filters is back. I can assure you I don't have all the filters set. Where are my filters, Twitch? Where's my activity? How will I know if things happen? We have 1 minute until an ad break. That somehow isn't broken. You know, you break everything. Where'd chat go, by the way? Oh, chat's still there. They're just not in a... I thought you guys were in a frame in this scene. I guess not. You guys are like connoisseurs of the different numbered farts that you can set off. So Twitch is breaking. Twitch is breaking at the moment. Yeah, am I still... I will not have a perception about whether or not I'm still online. Access denied. Oh, no. There it goes again. Everything crunched. 0 viewers. All filters set. Everything's broken. What's going on the phone over here? I don't know, man. Things are looking up. Everything around us is breaking. Including the things that I'm trying to test right now. Honestly, we should see the output looking like this. guess I could do that with the gain. Kind of, not really. Look at that beautiful sweep, though. But then look what happens to the amplitude. Look at that. As the frequency goes up, it's just cutting. It really feels like something's happening that isn't supposed to happen on this thing. If I cut everybody. Now we just don't see anything happen. So, like, it is doing a thing. The problem is I don't know what else would be wrong with it, right? I think it's really down to adjusting. We have so many components in this circuit, and everything kind of seems to be running right. I think maybe it's just getting the nuance of the different gains set up. There's just a little tweaking that I need to learn how to do. That's kind of what we've been doing today, is sort of learning how to get this stuff adjusted. So it's hard to see with this one up. Just turn that off. And the filter is open on both ends. So low pass all the way up, high pass all the way down. Resonance is, of course, that's so weird. I guess that's just the system oscillating, but we take it to where it's not oscillating. We can see there is something going on here. We are seeing those frequencies. It's just not high amplitude. So if I turn up the high gain and I go positive, hold on, I gotta bring these, I need like these 4 pictures up from this thing that tells me what direction I'm going in and what I'm actually adjusting for. Because yeah, if I filter out the lows so that we're only getting the highs, and then I adjust the high frequency gain in positive direction, we should see stuff start to appear, but I'm not seeing it. Oh, I need to do a Caremark prescription. Ooh. Down detector has AWS outage reports. Is it finally happening? Have they finally destroyed all of our infrastructure? The airburst nuclear armaments have gone off. Look, what I don't get is that I'm just not. There's nothing. There's nothing on the output. Why is there nothing? Oh, we're back from the ads. Welcome back, everybody. That's 3 minutes of hell. So what I'll do when I'm adjusting these is typically like nothing will happen and it'll just start going crazy, and then it becomes completely and utterly out of adjustment, and I have no idea where the adjustment is. Yeah, we got down detector with AWS outages. That's fun. So I don't know what I'm doing. I think maybe I need like audio to put into this thing. I need to build like a little amplifier circuit so that I can turn like a Walkman into a plus minus 5 volt machine that'll give me some kind of audio that I can pipe through. That, or if I take a VCO maybe at that level and I can adjust for that. It just seems weird. I've been trying all this stuff to try to get like frequency sweeps and noise. I mean, maybe I just need to put the put some white noise into the Focusrite. No, but that's not going to be at the right volume level. That needs to go into an amplifier that will then take it to Euro rack levels. I only have so many things that can produce noise. I think this thing will. I think the Teensy will if I set the output to noise. So maybe I can make a 4th category on this thing and set that to do the proper type of noise with as many frequencies as I can get in there as possible. Pink noise, I think they call it. But all right, well, look, it's getting on in the afternoon, and usually I'd like to go longer than this, but right now we have been flailing. I'm flailing right now. I don't know what's going on with this thing. I've tried to set it like 3 times. I can kind of get it to operate properly using noise, but I think what I'm going to do is I'm going to open up 3 copies of the manual and sit down with a pot of coffee and get that adjusted to where I'm reasonably comfortable that things can actually like do what they're supposed to. And then I need to do like I don't know, maybe I do need to open up the copy of Ableton 11 that I have and actually have this thing do that. But it won't do it. It'll do it at like consumer level. So I'll still need an amplifier for it. I'll need like an outside source input into modular synthesizers. Add audio track, input send, M oscillator, M noise generator. Oh, I don't know if I'd have to get these plugins, but M audio still exists, so. Disable oscillator, set audio to an external output on your audio interface. Input you want to use, for example, select input 3, enable input monitoring. But this is, I guess whatever audio interface you have, they're assuming it does modular levels. Yeah, and then we turn on analysis in order to get, but I mean, my own FFT should be showing me stuff like this. It should look kind of like this. These right here. But we haven't really been getting these responses out of it. So I'm a little frustrated. Maybe we'll go to actually like build stuff tomorrow. Tomorrow's Friday. We can relax a little bit and maybe I can build that dual Vactrol and we can finally get that thing back together. I'm gonna do the end card right now. We're gonna wrap it up before all the leaf blowers descend upon my window. It already smells like 2-stroke fuel in here, so I should probably get out of the basement. So I'm gonna be back tomorrow. We will be doing Eurorack stuff, but we're gonna be working on different things. We'll try to like build something instead of sitting here and scratching our heads, because I thought I could figure this out today. I can't. The FFTs coming back out of this thing are weird. Modern scopes are awesome though. Being able to have access to the fast Fourier transfer in the way that we have has been really cool, and I hope we can appreciate using one in the future. Although I don't know how many like spread spectrum sort of frequency response things. I've got a table full of filters here, so maybe we will use it in the near future. But until next time, I bid you farewell. What am I looking at here? Let me just take a quick look. That vertical video format is very strange. It's very strange. It's framing me in weird ways. I don't know if I like it. I'm like 2/3 of the whole thing. It's so weird. I'm also going to try to sleep. You guys remember that? I don't know what that is. Let's see who's on Twitch. I wonder if Gonad... No, Gonad will decide to go live just a little bit beyond when I stop, so that when I sit down in the evening and look at Twitch, I will think, oh no, I should have rated him. Oh, something went wrong. An Amazon company. That's funny. That is funny. So Twitch is in the process of shitting the bed. Must be nice for the people who are on the front page right now, but right now it's I can't get that. Let's get the scope out. Something went wrong. An Amazon company. So we don't know if anybody's live. We just don't know. Wonder if that could have gotten me to the front page. Oops. They do front page, you have to like apply for it now, so it's no chance that I'm getting that anywhere before we get Burn the Subs running. Well, my bots still work. I don't know about Twitch's, but mine do. So I can hit the end command here, and you can see that I will be back in approximately... Oh, I can't send chat messages. So, okay, so the filters don't work. Nothing works. Everything's broken. Amazon is on fire, and the real Amazon's on fire too. We're dead. We're all dying. We're all going to boil to death on this planet, thanks to Amazon screwing everything up and big data centers. Join me next time, where there won't be a next time. It'll just be just a burning shop. Yeah, apparently Twitch has completely shit the bed. It looks like I still see Rabaz over there, so we can't chat. I can't send chat messages, so I can't do the end card. But I'm going to be back tomorrow, and we're going to work on more of the filters. I'm hoping we can put the MS-22 aside. It seems to work great. I just don't know what I'm doing. I don't know if I'm adjusting it correctly or not. And the views that I'm getting of the filter, oh, Smith Clay was able to send it. I'm not, I can't. I'm gonna reload my monitor page and see what happens. It's not looking good. It's not looking good, folks. Oh, something's coming back. Hang in there. We are loading your activity. Oh, I'm sure. Access denied. You have all filters set. Every kid on the East Coast just got home from school. Oops, what the hell? What did I do? Oh, somehow I opened up a system monitor in Firefox. Process manager. Let's just see what I can do here. Exclamation point. That's right, school's starting up again, right? It's about that time of year. I wonder what that'll do for our viewer numbers. Well, okay, I don't have any monitoring stuff, so I can't do the end card. And Smith Clay doesn't have protection, even though Smith Clay can actually send messages. There are others who are out there who can't, because everything just completely pooped the bed. I'm done. It's about that time. So this has gotten very frustrating, adjusting the filters. I don't know. We'll figure this out later. I'm gonna let Twitch stew for a little bit because somebody tripped over an Ethernet cable and now everything is breaking throughout the entire system. I'll see you guys tomorrow. You can catch me on Discord. There's a Discord command. You can't use it right now because you can't chat. You can do it off hours. That works off hours. You can check for the Discord link because that's really my social media now. I've dropped X, or I'm never gonna stop calling it Twitter. Let's be honest. I've dropped Twitter, and Blue Sky hates me. So yeah, it's Swizzle Circuits and Smith Clay are the only people who can talk or something. You know, everything's broken. We'll fix it tomorrow. We'll see you then. Right? Bye. So stupid. I don't know. Hey, just go to the technical difficulties because now it's actually not lying. Now there are actually technical difficulties, so the page makes a whole lot of sense, huh?